Hey guys, welcome to Capturing Christianity. I'm Cameron Bertuzzi. Today I'm hosting a debate on the channel between Dr. Andrew Loke and Dr. Daniel Linford on whether or not physical reality has a cause or a beginning. The full title of the debate is in light of, what is it? In light of, I should know this, I should have it right in front of me and I don't. Dan, help me out here.
Physics.
In light of contemporary physics,
we should not accept that physical reality has a cause or a beginning.
There we go. It's like literally in the title of the video. I've been staring at it all day and I can't remember. It's actually late here. We don't normally stream at this time. But anyways, I'm not going to give excuses. But I'm super excited about the debate. I actually want to do what we typically do here with debates is jump right into the material. So I'm just going to quickly introduce my guest, give you guys a quick rundown of the way that the debate is going to go, and then we're going to jump right into the opening statements. So this is Dr. Linford's first time on the channel. He recently received his PhD from and was a Binsland Fellow at Purdue University. Is that the right? Is that the right way to say that?
Billsland, I think is the pronunciation.
Billsland, okay. Well, his research straddles both philosophy and science. His philosophical research is at the intersection of philosophy of science, particularly philosophy of physics and philosophy of religion, and his core interest in the philosophical foundation of physical cosmology ties together both philosophical areas. It's a little about Dr. Linford. Dr. Loke, he's been on the channel a few times. He's a fellow of the prestigious International Society for Science and Religion and associate professor in the Department of Religion and Philosophy at Hong Kong Baptist University. After graduating from the Faculty of Medicine, National University of Singapore, Dr. Loke worked as a medical doctor for 7 years. Pretty impressive. He then completed his MA in philosophy at Biola University and PhD in theology at King's College, London. So since Dan is taking the affirmative, he's going to go first. The way that we've got it structured, we've got 12-minute opening statements, followed by 10-minute rebuttals, first rebuttals. Then we're going to enter into a time of structured Q&A. So we'll have 25 minutes for each person to ask the other debater a set of questions that they have prepared in advance. They've actually shared their opening statements as well. So this debate you're about to watch is going to be very, what's the term I'm looking for? There's going to be a lot. There's going to be a lot of philosophical stuff going on in this debate tonight. And that's usually what happens when you share openings in advance, is that you get a chance to kind of really think about what the other person is saying. And so it's going to be very dense. There's going to be a lot of content here for you guys. I think you're really going to enjoy it. So then after the prepared Q&A that we have, we're going to switch to some audience Q&A if we have time. We'll see how the debate.
You have a bit of an echo. I don't know where it's coming from, but
yeah, I think it's actually from Andrew. He did offer to get some headphones as well. Do you have headphones, Andrew, that you can plug in?
Okay, let me go and try to get one.
Okay, no problem. Yeah, I think it's from, because you're using headphones, I'm using headphones. The only way that there could be any echo is from Andrew. Unfortunately, this is kind of what happens when we're doing something live. We run into issues like this. But no, I think it does actually make sense, and I'm glad that you pointed it out, that it's better to kind of get it under control now before we get going and stuff. So, but that's basically the structure of the debate. Got openings, rebuttals, the structured Q&A, and then we may have time to do some Q&A with the audience. I'll be keeping track of time on my phone. And Dan, was there something? It seemed like you kind of wanted to say something, or if not, no big deal.
No, I'm good.
Okay, great. Well, while we're waiting, there we go.
Is it better now?
Yes. Yeah, I don't really hear the echo anymore. Yeah, that sounds better. Okay. Great. Perfect. Okay, so as I mentioned, as Dan is taking the affirmative on the debate topic, then he's going to go first. He's got 12 minutes for his opening statement. So Dan, whenever you're ready, feel free to take it away.
Yeah, okay. Right, well, I want to express my gratitude to Cameron for extending the invitation, and to Andrew for joining in this exchange. I'm genuinely pleased to be part of this discussion. Tonight, I will argue that we shouldn't believe physical reality had a cause or a beginning. I don't know whether physical reality could be beginningless, or if physical reality could have begun without a cause. Instead, my view is that we don't currently have good reason to think that physical reality did have a beginning or a cause. We often hear that physical reality began in the Big Bang. Instead, we should understand the Big Bang as an evolution from a hot, dense state and not from an absolute beginning. As Alan Guth has said, the Big Bang theory never was a theory of the bang. It said nothing about what banged, why it banged, or what happened before it banged. For physical reality to have a beginning, there must have been a beginning not only to our past, but also to the past of all of the spatial regions beyond our physical horizon that by definition we have no access to. Viewers may be aware of various singularity theorems like the ones proven by Penrose and Hawking or by Borde, Guth, and Vilenkin. However, theorems are mathematical results and apply to reality only insofar as reality satisfies the assumptions underlying the theorems. The trouble is that given a theorem conjectured by David Malamud and later proved by G.P. Manchak, we will never gather sufficient data to determine whether space-time regions outside of our horizon satisfy those assumptions. Hence, even if physical reality does satisfy the singularity theorems, we couldn't know that it does. Physical theories apply to limited domains. When we trace singular models of the Big Bang back in time, the energy density and space-time curvature surpass any finite domain. Consequently, the singularity theorems themselves strongly suggest that if the visible universe has a past beginning, it lies outside the scope of current physics. The direction of time might be explained in terms of physical reality beginning with a low entropy state. However, as Hugh Price notes, a low entropy state is just as likely to occur at the beginning as at the middle of time, so to speak. Thus, physics itself does not tell us whether physical reality had a beginning. But can philosophy tell us whether physical reality had a beginning? Well, no. The arguments for a beginning to physical reality, whether purely philosophical or scientific arguments, have only ever aspired to show that the duration of the past is not infinite. For example, some philosophers have claimed that if the past is infinite, then various supposedly impossible scenarios involving infinite hotels, grim reapers, or whatever would be possible. We're supposed to conclude that the past couldn't be infinite. Let's put to one side the fact that I have doubts about all of those arguments. Even if we knew that the past is not infinite, we still would not be able to conclude that physical reality began to exist. I know that sounds odd. Surely you might think, if the past is not infinite, then the past is finite. And if the past is finite, then physical reality must have a beginning, right? Well, no. In order to understand why, we need to understand the distinction between metric and non-metric time. We are familiar with metric time from everyday lives. We measure metric time on our clocks. To grasp the distinction between non-metric and metric time, consider an analogy with the real line, envisioning its points as analogous to instants in time. Picture the real line as a sequence of labeled points, each marked by a number. Calculating the distance between 5 and 2 calculating the distance between 2 points on this line involves subtracting their labels. For example, the distance between 5 and 2 is 3. Now, like in non-metric time, to a set of points without labels. Without these labels, determining the distance between any 2 points becomes impossible. While in our daily lives we employ clocks to measure the duration between 2 instants, certain situations may present non-metric time. In these circumstances, the absence of labeled points means we cannot construct clocks, as there is no inherent information about the duration between 2 instants in time. Now, various cosmological models include an initial non-metric segment. We can talk about those models if you'd like, but the point is that if the initial segment of past time is non-metric, then there would be no fact as to how long the past is, and the past would be neither finite nor infinite. Hence, even if we knew that the past is not infinite, we still wouldn't be able to conclude that physical reality began to exist. There is no particularly strong reason to prefer the view that the past is finite over the view that the past includes a non-metric interval. Therefore, there is no particularly strong reason to conclude that physical reality had a beginning. Suppose we did have good reason to conclude that the past history of physical reality is finite. In that case, we still should not conclude that physical reality began to exist. Again, I know that this sounds weird, but on Andrew's view, God entered time when God created time. Since Andrew thinks that past time is finite, God, like everything else, has existed only for finite time. Hence, Although God has only existed for finite time, God is beginningless because God entered time from a timeless state. If God can be beginningless despite being finite to the past, why not physical reality? Indeed, a variety of proposals in contemporary physics, such as loop quantum gravity or Julian Barber's approach to canonical quantum gravity, have suggested that physical reality could include a timeless aspect. If physical reality has a timeless aspect, then since timeless entities do not begin to exist, physical reality might not have begun to exist. According to the causal principle, everything that begins has a cause. If Andrew could show that physical reality began to exist, then the causal principle could help him to show that physical reality had a cause. But there's another principle, called the material principle, that could hurt Andrew's case. The material principle says that everything that begins to exist arises from rearranging pre-existing physical stuff. If the material principle is true, then physical reality couldn't have begun to exist because physical stuff couldn't have existed before physical reality existed. The material principle is just as well supported from our experience as the causal principle. Italian villages don't just appear out of nowhere. They arise like tables, chairs, planets, and stars from rearranging pre-existing materials. Likewise, science appears to presuppose the material principle. So for each of the reasons to believe the causal principle, there's a corresponding reason to believe the material principle. You might say that there is a symmetry between the two. So Andrew needs an argument to break the symmetry. Without a symmetry breaker, we have no good reason to believe one without the other. Perhaps someone will object that God can make new objects without rearranging or modifying pre-existing physical stuff. But anyone who makes that argument has misunderstood me. The causal principle and material principle, if true, are good candidates for metaphysically necessary principles. Andrew argues that sensible scientific theories presuppose the causal principle. Similarly, advocates of the material principle contend that given God cannot perform metaphysically impossible actions, the principle should be presupposed by any sensible theological theory. Fundamental physics is a branch of physics that attempts to account for the rest of physics. In fundamental physics, explanations are expressed mathematically, and not in terms of causes. Bertrand Russell once suggested that as science matures, explanations in terms of causes are replaced by explanations in terms of mathematics. But mathematics on its own doesn't tell us how the world is. We need to interpret our mathematical equations, and there's ongoing debate about how we should do that. The big question is, do our equations contain something that should be interpreted as causation? Causes make things happen, and usually causes happen before their effects. If we could find something in our equations that always goes from the past to the future and can't go backward, that would be a good clue for causation. In our everyday experiences, some things only go in one direction. We've all seen eggs fry, but we've never seen eggs unfry. However, fundamental physics doesn't include processes that only move in one direction. The equations work just as well backward in time as they do forward. According to a long tradition in physics and philosophy, the fact that some processes only happen in one direction has an explanation in terms of laws that treat time symmetrically. But maybe causation doesn't have to involve something in the past causing something in the future. Does fundamental physics include relations at a fixed time that we can interpret as causes? Well, the answer is still no. Take general relativity, for instance. In this theory, the characteristics of neighboring regions of spacetime constrain each other, but both regions constrain each other in the same way. We cannot pick out one region as a cause and the other as an effect. Reflecting on these issues, many philosophers and physicists see causation as real, akin to blocks of ice. Just as blocks of ice are explained in terms of water molecules, causation must be explained by underlying physics. If so, causation applies only to processes within physical reality. Physical reality itself couldn't have a cause. Under a broader understanding of causation, one that doesn't require causation to be asymmetric, causation wouldn't be excluded from fundamental metaphysics. But in a broadened conception of causation that drops the asymmetric distinction between causes and effects, we lose the cause-effect distinction. Without the cause-effect distinction, physical reality couldn't have a cause, and physical reality couldn't be an effect. In sum, we don't know whether physical reality had a cause or a beginning. Physics cannot help us. The observable universe expanded from a hot, dense state, but this doesn't tell us whether physical reality began. Philosophy can't help us either. We don't know whether physical reality includes an initial non-metric segment, and we don't know whether physical reality includes any timeless aspects. We don't know whether physical reality had a cause either. We don't have a good reason to adopt the causal principle without adopting the material principle. Lastly, causation plausibly has a physical explanation, and if so, physical reality as a whole couldn't have a cause. Now I'll turn things over to Andrew. Thank you.
All right. Thank you for that opening statement. And I just wanted to kind of remind you, especially if you are just joining us, the topic of the debate tonight, I've got it written out. I had to go look through our email exchanges just to make sure I got this correct here. But in light of contemporary physics, we should not accept that the totality of physical reality had a cause or a beginning. And what you just heard was Dr. Linford's opening statement. We're going to turn it over to Andrew. He's got 12 minutes for his opening statement. He's got some slides prepared, so let's go ahead and turn to that now.
Yep.
So Andrew, whenever I can see them. Whenever you start talking, I'll start the timer.
All right. Okay, thank you, Cameron, and thank you, Daniel, for joining the discussion tonight. So the motion of debate is, in light of contemporary physics, we should not accept that the totality of physical reality had a cause or a beginning. Now, the context of this debate is the cosmological and teleological arguments for the existence of God. Now, by God, I'm referring to a creator of physical reality. Now, a creator is a kind of cause, but a designer is a kind of creator. Now, Linford attempts to deny this conclusion by arguing for the motion. I object to his attempts for the following three reasons. Firstly, contemporary physics by itself does not provide a complete description of reality and is not able to rule out a cause or a beginning. Secondly, contemporary physics depends on deductive as well as inductive reasoning and observation, and deductive reasoning and observation can be used to formulate arguments to show that there is a first cause creator. Now, note that if an argument is deductively valid and the premises are true, the conclusion is true. Okay, so this is an important criteria for determining truth. And thirdly, contemporary physics indicate that physical reality has a high degree of order, and this is evidence that there exists a designer. Okay, so I'm going to explain these 3 points in detail. Now, concerning the first point, I think actually both Daniel and myself agree, so I don't have to spend much time about it, because now the current proposals of physical cosmology concerning what happened with the Big Bang are proven, given that we do not currently have a well-established theory of quantum gravity. Now, concerning the second point, if an argument is deductively valid and premises are true, the conclusion is true. Such an argument can be formulated for a first cause creator. And here I present a 13 steps cosmological argument. Premise 1, if something, say X, begins uncaused, then some other things, such as Y, which began or could begin to exist around us, would also begin uncaused. Why? Because firstly, there will be no cause that makes it the case that only X rather than Y begins uncaused. Secondly, the properties of X and the properties of Y, which differentiate between them, will only be had by them only when they have already begun to exist. And thirdly, the circumstance around us is compatible with the beginning of Y. And so these 3 points imply that there will be no difference between X and Y where beginning to exist uncaused is concerned. Okay, and therefore, if X begins uncaused, Y would also begin uncaused. But it is not the case that Y begin uncaused, right? So Y could be, say, for example, a sudden increase in strength of electric field around us. No, we don't experience that suddenly begin uncaused and killing us, right? And therefore, it is not the case that something began uncaused. So this is a modus tollens argument, right? So I've already explained why the premises are true, and therefore the conclusion is true. So the conclusion implies that whatever begins to exist is dependent on cause to make it the case that is, say, for example, X rather than Y that begin to exist. And I call this the causal principle. Okay, so given the causal principle, I then go on to show that there exists a series of cause and effects and changes. So for example, I begin to exist, I came from my parents came from their parents, etc. Now, this series either has an infinite regress that avoids the first cause, or its members, so either it's infinite or it's finite. If it's finite, then either the members are joined together like a closed loop that avoids the first cause, or the series has a first cause. And then in my book, the publications, I've shown that it's not the case that it's an infinite regress or a closed loop. And therefore, and in fact, there are multiple arguments for these 2 premises, such as the argument from the viciousness of dependence regress, which is based on the causal principle, which basically shows that things which beginning of existence are dependent on causes. Now, there cannot be an infinite regress or a closed loop of dependent relations. Just as if, say, for example, if I have no money and depend on Daniel to give me money, but Daniel also have no money but depend on Cameron, if everyone is like this, right, no one will ever begin to have money. What is required is somebody who is a first source of the money, right? So likewise, I argue that there must be a first cause of existence. There must be an independent first cause. Okay, so now since that is the case, we need to ask what is the first cause. Okay, now since the first cause is the first, it must be uncaused. And since whatever begins to exist as a cause, the first cause must be without beginning. And since every change is an event, I define a change as an event, right, which has a beginning as something or part of a thing gain or lose a property. The beginningless first cause is not a change or event, right? It is not an event such as, for example, the Big Bang, for example. Rather, it is something that is initially changeless. And by initial, I refer to a first in the series, the first in the series of states ordered causally, not first in the series of changes, events, or temporal state series. Okay, so the first cause must be initially changeless. Now, in order for the initially changeless first cause to cause the first change or effect or event, regardless of whether it's a Big Bang or whatever, from an initially changeless state, the first cause must have the capacity to originate the first event in a way that is undetermined by prior events, since the first cause is the first. And moreover, it must also have the capacity to prevent itself from changing, otherwise it wouldn't be existing initially changelessly and beginninglessly without the event or change. And these two capacities imply that the first cause has libertarian freedom, which implies that it is a personal creator. Okay, so I've already shown that there is a personal creator of the universe, which is what I mean by God. Now, but in addition to this, I can offer additional reasons, and by combining the cosmological argument with the teleological argument. So, and goes on to argue that in order to bring about the first events that result in the formation of the highly ordered physical reality with billions of galaxies and stars, the first cause must be enormously powerful and highly intelligent. And a first cause that is uncaused, beginningless, initially changeless, has libertarian freedom, highly intelligent, and enormously powerful is a creator, and therefore a creator exists. Now, in his publications, Daniel objects to the causal principle by arguing that the direction of time does not appear in our best microphysical theories. Now, I have a number of replies to this objection. One reply is that current microphysical theories does not provide a complete description of microphysical reality, but only a certain aspect of it. And we must be careful to note that the equations of physics do not provide an exhaustive description of reality. So to illustrate, the quadratic equation, x squared minus 4 equals 0, for example, can have two mathematically possible results, 2 or negative 2. However, if the question is how many people carry the computer, the answer cannot be negative 2, right? And this conclusion is not derived from mathematical equations. The equations doesn't tell us that, right? But it's actually from causal or metaphysical considerations, because we know, based on these considerations, that negative 2 people lack the causal powers to carry a computer. So this shows that equations cannot provide a complete description of reality. We need something else. And so this means that even if a cosmological argument, even if a cosmological model is mathematically possible, it cannot be the correct model of the universe if it's metaphysically false. Okay, so this is an important point to bear in mind. Now, on the other hand, philosopher of physics Christopher Weaver has noted that the word interaction in scientific and physical research context is a causal term. Okay, so the Oxford Dictionary of Physics defines an interaction as an effect, which means that there is a cause, right? Effect, involving a number of bodies, particles, or systems as a result of which some physical or chemical change take place in one or more of them. Okay, and Weaver notes that there are 4 fundamental types of interactions between fundamental entities in our best physical theories: the strong and weak forces, electromagnetic and gravitational interactions. And so this implies that causality and change are present in fundamental physics. And moreover, the modus tollens arguments, which I presented earlier, has already demonstrated that whatever begins to exist has a cause. Okay, so this would include whatever in fundamental physics as well. Now, Linford also mentioned that he claimed that there are live physical theories according to which space-time is reducible to more fundamental non-space-time structures. Now, he acknowledged that this view is controversial. I would like to highlight 2 other problems. Firstly, Daniel fails to consider that on either the substantival or the relational view of time, the existence of events or change would be a sufficient condition for the existence of time. An event is defined as involving something gaining or losing properties. Gaining, losing takes time. The states of having gained or lose a property or having happened, for example, will be regarded as a beginning, which implies the existence of time. Now, as explained earlier, the existence of events, such as interactions, which is also implied causality, is well established in fundamental physics. So in actuality, the physical theories mentioned by Linford deny our ability to measure time, but not denying time itself, which is implied by the existence of events. Okay, so this is the first point. And there's a second problem with Linford's claim, and it is that regardless of whether space-time is reducible, the series of changes which we observe, right, which we know do exist, will still need to have a first cause, as I have already demonstrated earlier. Premise 7 and 8 of my argument. And given the rest of the premises of my cosmological argument, the first cause would still be a creator God. And therefore, the possibility of the reducibility of time does not rebut my argument, since my argument primarily concerns events or changes which undeniably exist and have beginnings as properties are gained or lost, regardless of whether time is reducible. And moreover, the conclusion of the arguments that the first cause is a creator with libertarian freedom can be deduced from the necessary conditions required for the first cause to cause the first event. Now, finally, let me say something about the teleological arguments, the argument for designer. Right, so if you look at this photo on the screen, right, you'll see the words "I was here." Now, you don't see anybody there, right? But you know that somebody must have been there before. Why? Because these words is evidence of a designer, somebody intelligent who have written these words. Now, think about the equations of physics which scientists discover, right? So these equations, there are thousands of them, like E equals mc squared, for example. Now, these are far more complicated and precise and sophisticated than these simple words "I was here." Okay, so you know that these words "I was here" couldn't have came by random forces or natural forces, right, such as the wind or the waves. They wouldn't have formed these words. Likewise, it is unreasonable to think that these equations, the information contained therein, is just formed by random or natural forces, right? And so I have formulated the teleological argument in this way, right? So contemporary physics indicates that physical reality has a high degree of order, and this order is either fundamentally uncaused or is fundamentally due to random causes, which I call chance, or non-random causes, either non-intelligent, non-random causes, which is regularity, or intelligent, non-random causes, which is design, or due to a combination of these, right? So using this syllogism, I demonstrated there are only these few possibilities. And then I go on to show that there are good reasons for thinking that this order is not fundamentally due to chance, regularity, or combination.
30 seconds.
But there's no good reason to think that it's not fundamentally due to design. Okay, and therefore, it is due to design. Now, why not chance? Because it is vastly improbable, right, that these billions of these particles could just follow these highly ordered equations, and the regularity hypothesis fails because it doesn't explain why there's regularity in the first place. And for the chance and regularity hypothesis to work, right, the high degree of order must already exist in the first place. And the uncaused hypothesis fails because unintelligent entities are blind to high degree of order, so they doesn't render such order probable, and therefore the conclusion is design. So in conclusion, there are different proposals for contemporary physical cosmology. Those that attempt to deny that the totality of physical reality had a cause of beginning are not based on well-established science. On the other hand, cosmological and teleological arguments are deductively valid arguments based on true premises, and therefore the conclusion is true. There exists a creator of physical reality. Thank you.
Okay, just about 12 minutes. So as I say, we're going to move into now a period of rebuttals, and these are about 10 minutes long. So Dr. Linford has 10 minutes for a rebuttal. Following that, we'll have Andrew provide his first rebuttal, and then we'll move into a period of questions. So Dan, whenever you're ready.
All right. Well, once more, I'd like to thank Andrew for agreeing to this exchange. Recall the subject of our debate. Given contemporary physics, should we accept that the totality of physical reality had a cause or beginning? Now, I have argued that since we don't know whether physical reality had a cause or beginning, we shouldn't accept that physical reality had a cause or beginning. I have not argued that contemporary physics shows that physical reality is beginningless, or that physical reality began without a cause. According to Andrew, something has a beginning if it has temporal extension, the extension is finite, and it has temporal edges/boundaries, that is, it does not have a static closed loop or a changeless timeless phase that avoids an edge. On that definition, so long as physical reality's past history isn't finite, physical reality did not begin to exist. If physical reality's past history includes only a finite number of changes, that wouldn't in itself show that physical reality's past history is finitely long. So why should we care whether the number of past changes is finite? Moreover, Andrew claims that the organization of physical reality is improbable unless physical reality was designed. But even if the order we observe in physical reality requires a designer, physical reality doesn't have to be caused. I'm here to debate whether physical reality had a cause or beginning, and not whether God exists. Physical reality could have existed beginninglessly in a disordered, chaotic state, only to be subsequently ordered by a designer. Unless Andrew can show the design argument is something relevant, I will set the design argument aside. Let's review what each of my arguments are and see how Andrew's arguments fail to rebut the case that I've made. I first argued that physics doesn't tell us whether physical reality had a beginning. According to Andrew, contemporary physics does not provide a complete description of reality, and we do not currently have a well-established or verified theory of quantum gravity. Since contemporary physics does not provide a complete description, contemporary physics cannot rule out the possibility that physical reality had a beginning. Likewise, contemporary physics doesn't provide us good reason to think that physical reality did have a beginning. Since we seem to agree on this front, I'll set the issue aside. I also argued that philosophy cannot help us to determine whether physical reality had a cause or beginning, because the philosophical arguments leave two alternatives to a beginning. Physical reality could include some timeless aspect, and physical reality's history could include an initial non-metric segment. For Andrew, either the past involves an infinite regress of changes, a circle of changes, or a finite number of changes. After ruling out an infinite regress or a circle, we are still left with two possibilities. First, there's the possibility that there's a timeless physical entity, so that the totality of physical reality did not begin to exist. And second, supposing the first change required a cause, the cause could have been a physical entity that existed in non-metric time. Andrew has argued that the first cause must be a person. He argues the first cause must have libertarian free will because, in virtue of being first, the first cause must have been undetermined by anything else, and because the first cause must be able to prevent itself from initiating change. These requirements do not show that the first cause possessed libertarian free will. An entity with libertarian free will must also be able to deliberate and weigh reasons for various actions against one another. Moreover, no sense can be made of the idea that a timeless entity has the power to prevent itself from undergoing change. Any entity that begins to change is not timeless. Hence, there is no need for a timeless entity to prevent itself from undergoing change. In contrast, an entity that exists in non-metric time might begin to change. There would be no need for that entity to prevent itself from initiating change, because there is no fact of the matter as to how long that entity has previously existed in non-metric time. Suppose physical reality's past history truly is finite. Physical reality might still be beginningless. For example, timeless physical entities appear in some physical theories, or in some interpretations of physical theories. And since timeless entities are beginningless, if physical reality includes any timeless entity, then physical reality is beginningless. But Andrew thinks that no physical entity could be truly timeless because all physical entities, he thinks, undergo change. But why think that all physical entities undergo change? In various publications, Andrew claims that quantum mechanical entities are always undergoing change. But Andrew is wrong. Any quantum mechanical system that is in an eigenstate of its Hamiltonian simply does not undergo intrinsic change. This is an elementary fact that you can read about in any quantum mechanics textbook. Moreover, entities undergo change when they possess a property at one time and lack it at another. Hence, entities undergoing change have location in time. Timeless entities do not have a location in time. Consider Julian Barber's approach to canonical quantum gravity, where all that fundamentally exists is a timeless distribution of properties in a high-dimensional space. While the high-dimensional points correspond to instants of time, they are not ordered by before and after relations. We intuitively think of instants of time like frames of a movie. When the frames are collected together on a film reel, the film reel provides the glue that sticks the individual frames together. Likewise, instants of time are related to one another by before and after relations. But the high-dimensional points are not connected by before and after relations, or indeed by any other temporal relation. The high-dimensional points are more like photographs scattered on a table than they are like frames on a film reel. Photographs scattered on a table can be constructed into a movie through the similarities between them. Likewise, the interrelationships between the points, what Barber calls the best matching condition, allow one to construct a timeline. Consequently, the fundamental substructure doesn't have a location in time. Instead, moments of time are located within this fundamental substructure. Hence, without a location in time, the fundamental substructure does not have a property at some time the substructure fails to have at some other time. Furthermore, since change involves a relationship between two times, change itself can be understood in terms of relations between locations within the substructure. The substructure is truly timeless in Andrew's sense. Barber's view is merely one example. As Christian Ruthrick has pointed out, structures appearing in a wide variety of different quantum gravity theories lack several or most of the features we would normally attribute to space and time, including relative locations of objects in space and time. In a recent paper, I argued that, according to several distinct views, temporal relations are not fundamental. Andrew has published a reply to my paper, but failed to engage with those arguments. Moreover, there may be timeless physical entities undreamt of in any of our physical theories. Andrew needs to provide us a convincing reason to think that there couldn't be any timeless physical entities. Does Andrew think that there is something about the nature of being physical that precludes being timeless? Andrew has argued that even if space-time is reducible, we observe a series of changes, and these changes must have a first cause. Hence, Andrew claims, the argument for a first cause can succeed, even if space-time is reducible. If we assume that there are causal chains, that causal chains must be finite, and that there are no circular causal chains, then I would agree that each causal chain must have a first member. But why is this relevant? On one hand, the first cause could be a physical entity. On the other, if space-time is reducible, then the totality of physical reality did not begin to exist. Let's discuss my third argument. We don't have good reason to adopt the causal principle without also accepting the material principle. For each of the reasons we might have for adopting the causal principle, there's a corresponding reason to adopt the material principle. Now, nothing that Andrew has said actually breaks the symmetry between those two principles. For example, Andrew has summarized his modus tollens argument for the causal principle. According to that argument, if anything can begin to exist without a cause, then all sorts of things would begin without causes. But all sorts of things do not begin without causes. Thus, nothing can begin without a cause. But likewise, we have a modus tollens argument for the material principle. According to that argument, if anything can begin to exist without resulting from the rearrangement of pre-existing materials, then all sorts of things would begin without resulting from the rearrangement of pre-existing materials. All sorts of things do not begin without resulting from the rearrangement of pre-existing materials. Hence, nothing can begin without being the result of rearranging pre-existing materials. Now the last argument from my opening statement. Causation plausibly has a physical explanation. If causation has a physical explanation, then physical reality as a whole couldn't have a cause. We agree that physics does not provide a comprehensive description of physical reality. Future physics might provide us with additional reason to think that causation has no underlying physical explanation. But equally, future physics might provide us with additional reason to think that causation does have an underlying physical explanation. We have no good reason to rule out from the armchair the possibility that causation has an underlying physical explanation. We agree that the mathematics we utilize in almost done. We
feel free to go ahead and finish out.
All right. We agree that the mathematics we utilize in fundamental physics needs to be interpreted. Again, the question becomes how we ought to interpret the mathematics. Andrew points to Wiefer's argument that fundamental physics includes various interactions, like the electromagnetic interaction, and that these interactions could be interpreted in causal terms. But interactions do not involve asymmetries that would make them good candidates for interpretation as the causal relation. Andrew claims that my arguments presuppose the direction of time is parasitic on the direction of time. the direction of causation is parasitic in the direction of time. That too is also mistaken. If you recall in my opening statement, I talked about reciprocal relations between space-time regions. In sum, we don't know whether physical reality had a cause or beginning. Andrew and I agree that physics doesn't tell us whether physical reality began. Philosophy doesn't tell us either. For all we know, physical reality includes an initial non-metric segment or some timeless aspects. We don't have a good reason to adopt the causal principle without adopting the material principle. Andrew hasn't broken the symmetry between the two principles. And lastly, since it remains unclear whether causation has a physical explanation, it remains unclear whether physical reality could have had a cause. Thank you.
All right, so it looks like we've gone about a minute over time. So, Andrew, you've got 11 minutes for your first rebuttal. So whenever you begin talking, I'll start the timer.
Okay, thank you, Linford. Thank you, Daniel. Okay, so now, firstly, he claims that he cites concerning the definition of beginning, right? And he argues that physical reality may have been beginningless, and there could be a timeless, beginningless physical reality. But I have already explained earlier on that this a timeless physical, a timeless thing, a beginningless thing, in order to cause the first event from it, you will need to have libertarian freedom. Now, and now, of course, he raised objection to this point. He says that in order to have libertarian freedom, the thing must be able to deliberate all this. But I don't think that the deliberation, for example, is a essential property of libertarian freedom. So that could be all omniscient by first cause, for example, and who don't need to deliberate, but who can still freely choose to bring about events without deliberation. And in that case, he will still have libertarian freedom in that sense. Now, Daniel also mentioned that order, a designer, is not the universe could have existed forever, but there's in chaos, and then there's a designer who ordered the universe, and in that case, the designer is not a cause. Well, I disagree. I think that in that case, a designer will be an efficient cause, right? Who designed who ordered the reality according to its purpose, right? So there will be a final cause there as well. Now. And so, for example, if my laptop has existed as pieces of random matter beforehand, and then I order it into a laptop, right? Then I am a cause for the state of the laptop, right, existing, right, in the way that it is. So a designer is a kind of cause, and therefore my teleological argument is relevant, right? It shows that there is a designer cause of physical reality as we see it now, which has a high degree of order. Now, and then Daniel claims that the first cause might be something physical. Now, I would like him to define what is physical, right? Because since he's the one who decided on the motion of the debates, I would like him to define what he means by physical. He hasn't defined it yet, even though he decided the motion, but he doesn't define what is physical. Well, on the other hand, my argument doesn't requires. My argument goes to show that there is a first cause who has libertarian freedom, who is personal, and who is also a designer, without having to worry about whether the creator is physical or non-physical, no matter how you define it, right? So even if you define physical in a way that whatever way you define it, right, there must still be a first cause with libertarian freedom and who has intelligence, right? And that's what I mean by God. Daniel also said that anything that begins to change is not timeless. Well, here I think he has confused what the modern notions, because I do not argue that the first cause is essentially timeless, right? So I only argue that it's timeless, but something which is not essentially timeless, but who is in the state of timelessness, not essentially, but who has libertarian freedom, can freely bring about the first event and thereby enter into time as well. Okay, so that's not a problem. Now he claims that non-metric, that there could be a non-metric, a first cause in non-metric time. In that case, it will be an impersonal first cause. However, I think the problem with that view is that such a first cause, which then brings about the first event, will be unstable, right? So if it's a non-personal entity and a physical entity, it will be unstable. It will unstably bring about the first event. Now, if that's the case, then it couldn't have remained in the initial changeless state beginninglessly, right? Because unstable means that it will only have existed in that state for a finite amount of time. It will be metastable, right? So it wouldn't have existed beginninglessly, right, without the first event. So that's the problem with Daniel's view. Now, he says, why I think that all physical entities undergo change. And now, as I said, this also depends on the definition of change. But as I said earlier on, my argument doesn't depend on, my argument for a God, right, doesn't depend on the definition of physics. Right? Now, on the other hand, he claims that there are physical entities that do not change. Now, I think that it is based on different definition of change, right? So we need to get this point clear. Now, let me share my screen here. Can I share my screen? Oh,
Yeah,
I can't share
one
my
second.
screen.
Let me get.
Yes. Okay. So, no, I can't. I still cannot share it. Why does it disappear?
I see your screen on our screen.
It looks
So I
like
want
it's
to
the PowerPoint is what's showing. But I take it you want to show
Okay.
something.
Okay. Let me get out of the PowerPoint. Okay.
I think it might have
this?
only shared the one window. It always
Okay, let me
right
share
now,
again.
black.
Okay, right. Thank you. Okay, can you see now? Okay, so
Yes.
let me share this article by Carlo Rovelli, which I just read yesterday. Right, so this article is by one of the leading proponents of the loop quantum gravity. Right, so he says very clearly here that there are different definitions of time. Right, so if we understand time as a relations between events, for example, then he says that used in this sense, when used in this wide sense, time is definitely present in LQG, right? In loop quantum gravity, you can say that something happens when something else happens. For instance, a particle is emitted when two quanta of gravity join. Also, we can say that two events are temporally adjacent, right? So what this means is that the events are truly present in fundamental physics, even in the most fundamental level in LQC, right? So it's only when you define time or change in a way that is, say, for example, talking about the passing or the flowing of passage of time, as, say, for example, in the dynamic theory of time, then in that sense, LQC doesn't show that that kind of time exists, right? But if you are talking about events, right, then definitely that exists. Okay, and so my argument is based on events. So my argument actually works on the B theory of time, right? My Kalam argument doesn't depend on the A theory of time. And so what Daniel mentioned doesn't rebut my arguments. Now, he also mentioned Barber's view of, now, again, Barber's view is based on a problematic definition of time, right? Again, he defines it as kind of flow, right? That's what what he means by time, and on the A theory. But as I said, my argument works on the B theory as well. So, yeah. Now, Daniel mentioned, he claims that the material principle is symmetrical to the causal principle. I argue, well, actually, that is false. Why? Because if something begins without pre-existing material cause or not from transformation, it doesn't mean that other things would also begin as such. Why? Because that something which begins without material cause could still have efficient cause, which determines that it came about in that way. So it doesn't mean that there's no cause at all, right? So it doesn't mean that everything goes, right? So there is still a cause, which means the case that that event happens. And whereas if you deny that there's efficient cause, if you deny any cause at all, right, you say something that just begin uncaused, then there will be no cause. That means it's the case that only X rather than Y begin to exist, right? So premise 1.1 of my modal slowness argument does not find a symmetry, right, in the Daniel's material principle, in Daniel's modal slowness argument for the material principle, right? And so there is a symmetry breaker there, which I just mentioned. Now, Daniel claims that physics does not rule out underlying. No good reason to think that there is underlying cause for physical reality, and he also talks about my view about interaction, which I cited from Weaver. Now, I have 2 points in response. First is that, as I explained just now, in events truly exist, right? So no matter how you define interaction, there are events, and these events can be understood as effects of something else. right? So there is causality there, and moreover, the modus ponens argument which I presented already shows that whatever begins to exist has a cause, right? So this shows that events, which are things which begin to exist, would have causes as well. So there are causality in fundamental physics. Okay, thank you.
All right, so now we're going to enter into a period of prepared Q&A, and these are going to be 25-minute sections. So we're going to start with Dan. He's going to ask Andrew a series of questions. And again, we'll go for about 25 minutes. I'll keep a timer here. And then at the end of that 25 minutes, we'll switch to Andrew asking Dr. Linford questions. So Dan, whenever you're ready.
All right. Right. So according to your opening statement, you agree that we don't know which quantum gravity theory, if any, is correct. You stated, we do not currently have a well-established or verified theory of quantum gravity, and for this reason, none of the current proposals of physical cosmology concerning what happened before the Big Bang are proven. And I agree. I would add that for the same reason, none of the proposed cosmological models that include a beginning have been proven either. Since we don't know which quantum gravity theory is correct, do you agree that we cannot yet construct a good scientific case for the beginning of physical reality?
Well, thank you for the question. Now, I want to clarify that not proven in a strict sense does not mean that there is no likelihood at all, right? So here I will refer you and the audience to the work of Aaron Wall, a physicist at Cambridge University. He has defended what is known as the generalized second law of thermodynamics, and he argues that this is widely believed to hold as a consequence of the statistical mechanical properties of quantum gravitational degrees of freedom. It is a good candidate for physical law likely to hold even in the full theory of quantum gravity. Now, if you want to debate this, you can debate with Aaron, right? Because in any case, the argument that I'm presenting today does not depend on this. Instead, I have provided even stronger arguments, right? Because I provided philosophical arguments which are proof in the strict sense, in the sense that they are deductive arguments based on true premises, and so the conclusion must be true, right? Regardless of whether the second law of thermodynamics holds or not. The case I'm presenting today doesn't depend on this point. Yes.
Yeah, so you brought up Aaron Wall's theorem. Aaron himself has said publicly that his result does not show that singularities cannot be avoided in quantum gravity, right? His result is a result about semi-classical gravity, not a result about quantum gravity. What he does do in his paper is that he briefly speculates about whether the result could hold. Now, there are a variety of people, including, for instance, Abe Ashtekar, who was the editor of the journal in which Wall's paper was published, who do not agree with the speculations that Wall has made, and also doesn't agree with the generalized second law. So it's just false to say that these are like widely accepted principles, or that we can just take Wall's result to show us something significant about quantum gravity. But in any case, I'm glad to hear that we, in some sense, agree that science hasn't provided a sufficient case for beginning of physical reality.
Yeah, so can I, just a quick rebuttal. So you mentioned that there are some people who disagree with his view, right? But I'm just wondering whether has those disagreements been published? So has Ashtekar published the reason why he disagree or not? Or because I'm going by what has been published so far, and I have asked Aaron about this, and he thinks that his view is still defensible, even though, of course, some people disagree. But what are the reasons for disagreeing, right? But in any case, I think it'll be a good discussion that you can have with Aaron. Yeah. So my case today doesn't depend on this.
Yeah, all right. Well, since your case doesn't depend on it, let's move on to the second question. It's kind of a related question, but I'm still interested to hear what you have to say about it. So some other friends of cosmological arguments, such as William Lane Craig, have defended their views using singularity theorems, such as the Hawking-Penrose theorem or the Borde-Guth-Vilenkin theorem. I think that given both the Mailman-Manshak theorems and the fact that we do not yet have agreed upon quantum gravity theory, we have no good reason to think that the singularity theorems tell us whether physical reality had a beginning. I'd like to hear whether you agree with that.
Well, I agree that those theorems by themselves do not prove a beginning. Right? But that does not mean that these theorems do not constitute good reason when taking into account other considerations, right? So in my book, I did mention other considerations alongside the BGV. And now, Aaron Wall has also corresponded with me on this issue. Now, he told me that theorems like BGV, even though by themselves it doesn't prove a beginning, but nevertheless, these theorems can place significant constraints on theoretical model building by ruling out a number of attempts to construct models which have no beginnings, right? So it does provide some kind of constraint, and if you take this constraint together with other constraints, you may actually construct a case where to show that all these considerations taken together indicates that, right, physical reality does have a beginning, right? It may provide some good reasons in that sense. Now, again, as I said, the case I'm presenting today does not depend on this point, right? So in fact, I'm depending on even stronger arguments, deductively valid arguments based on true premises. So if you're interested, you can debate this point with Aaron Wall.
Yeah, well, look, how would you respond to the point about the Mellman-Manchak theorems that I asked in that question?
Yeah, so this theorem, it says that there may be some assumptions that we currently do not know that if I understand it correctly, right, there may be some unknown assumptions that may cause these theorems or whatever we predict, it doesn't happen in the pre-Big Bang scenario. But I suppose this kind of objections can also be raised about, say, for example, about the future, right? So I mean, in the future there may be some assumptions. I mean, there may be some things that change that which make it difficult for us or impossible for us. Would we say that because of some unknown conditions in the future, therefore we cannot predict that if I jump down from 10 stories 1 hour later, right, I will most likely die? Well, I don't think so, right? So
Well, look, maybe I should just describe what the theorems tell us,
Okay.
and then you can respond to that. So folks might be familiar with the fact that nothing can move faster than light. And one of the consequences for that is that we're limited in the amount of information that we can receive from the universe, right? So all the locations from which we can receive light is called our pass light cone. Now, there are, so that's just a piece of machinery that we need to state the theorem. So we can wonder whether space-time has various kinds of global properties. In this case, we're wondering whether space-time has a global past boundary, right? I mean, that's part of what we mean by beginning. Now, if it turns, so any observer in our universe can only look into their past light cone, right? So if you take all of those past light cones from all of the possible observers, from all of the possible locations that any observer could ever be in, okay? So that's all the information any observer, located anywhere, could ever receive. And then you ask, can I build another space-time with an entirely different set of global properties, but that includes all of those same past light cones? If you could do that, then it would turn out that for any possible observer located anywhere in space-time, they wouldn't be able to distinguish the two cases. So that's what the Mellman-Manchak theorems say, is they say that we can't determine what the global properties of space-time are because we can always construct another space-time that's observationally indistinguishable and that has an entirely different set of global properties.
Yeah, thank you for your explanation. But as I said earlier on, I refer to future events, right? I mean, future events are also not in our past light cones, right? They are in the future, right? So I suppose you can also construct other possible models about the future. So does it mean that we cannot predict about the future? Well, again, I don't think so, right? So
well, but hang on. What allows us to make predictions about the future is the fact that we have something like the uniformity of nature thesis, right? So the laws of physics, if they continue to hold in the future, will tell us what happens if you jump out of a window, for example, right? They'll also tell us, if you plot the trajectories of the planets around the sun, you can predict when the sun is going to rise tomorrow, right? Well, you can ask, suppose that I restrict myself only to space-times where in the neighborhood of every point, the laws of physics are satisfied. And it turns out that one of the corollaries to the Mailman-Manshak theorems is that that's not enough. In other words, even if I restrict myself to spacetimes where in the neighborhood of every point the same laws of physics that we observe are satisfied, or even a wide variety of other laws that you could imagine, that's not enough to get rid of that observational indistinguishability. It's not enough to be able to say what the global structure of spacetime is. One part of what that means is that when we make projections using our laws, those projections do not suffice for distinguishing one set of global properties over another.
Yeah, that's right. I understand that that's what you're trying to say. Yeah. But then again, the point of the future, right? You mentioned the future. You're assuming that the laws of nature will be uniform, right? Will apply in the future. But then the laws of nature have to take into account ceteris paribus conditions, right? So there may be conditions that change in the future that result in the events that we predict don't happen. Yeah, so now you're saying that maybe in the past, there are some conditions. I mean, you can construct other models that are also consistent with these laws. I mean, but that will also require some other assumptions, right? Some other assumptions or some other conditions, and I'm saying that those other assumptions or conditions may also be present in the future that cause us to not be able to predict.
Well, sorry. The statement is that given any law described by a set of differential equations that we can describe locally, then this kind of observational indistinguishability is going to hold, right? So, like, I don't understand what the ceteris paribus conditions are supposed to do for you here. Usually, the way that people understand induction, you've made a lot in various debates you've had and other writings that you've produced of the notion that there are some predicates that are projectable and some that are not. And the idea here is that we can't use induction to solve the problem posed by the Mailman-Manshak theorems because all of the projectable predicates, that is the predicates that correspond to these underlying regularities, whatever those regularities might be, are going to be locally satisfiable, right? So like it doesn't solve the issue to appeal to induction. But anyway, let's move on. So
yeah, in any case, the argument I'm presenting today doesn't depend on induction. Yeah, anyway, yeah,
right, and that's why I'm moving on. So I've claimed that there exist various physical theories or interpretations of physical theories that posit timeless physical entities. Conversely, in your initial statement and publications, you asserted that these theories or interpretations do not involve timeless physical entities. For example, in your opening statement, you stated, these physical theories mentioned by Linford are denying our ability to measure time, but not denying time itself. Of course, I never denied the existence of time. Time clearly exists, right? Instead, I suggested that time might be explained in terms of more fundamental physical entities, which could themselves be timeless. In any case, you've not demonstrated the theories that outlined in my opening statement definitively exclude timeless physical entities. In my opening statement, I listed two theories, first loop quantum gravity, second Julian Barber's approach to canonical quantum gravity. And I wanted you to explain why neither of these two could involve timeless entities. Now, I should say, for the audience's sake, I wrote this question before I saw what Andrew's rebuttal was going to involve. But still, I want to give Andrew a further chance to explain why it is that loop quantum gravity and Julian Barber's approach to canonical quantum gravity cannot involve timeless entities.
Okay, so I'd like to make 2 points in response. The first point is that you're saying that their theories include some timeless aspect, right? But my response is that what they mean by timeless is not actually timeless in the sense that I'm using it, in the sense that it's relevant to the cosmological arguments. Because what they mean by timeless is not really the absence of events, or which I define as change, right? And so, as I mentioned just now, the absence of events is a necessary condition for timelessness. Why? Because if there's any event, then there is time on either the substantival or the relational theory of time. And so, if you want to use these theories to rebuts the cosmological argument I presented, then you will need to show that how these theories are relevant, right? But as I explained, right, otherwise you have failed to rebut the argument. But then you have not shown that they are indeed relevant. And so you have failed to rebut the arguments because those theories, when they talk about timelessness, they're actually talking about something else, right? Rather than they're not talking about the absence of events, for example.
Yeah. So look,
So
I don't think they are.
And
Sorry,
second,
I don't think they are talking about something else. So when
I
you
mentioned I
say
have 2
that
points.
they're okay, go ahead. I didn't mean to interrupt you. Go ahead.
Okay, sure, no worries. Yeah, I'll finish my second point, and then you can question me on that, on these 2 points together. Okay, so and yeah, by the way, I haven't finished my first point, right? Because I want to continue by saying that I don't think there is physics without events. Why? Because if you want to talk about emergence or interactions or process or equations, all these describe events. They describe how something is related to something else in events, right? So, and now you haven't defined what you mean by physical reality, but so let me say what I mean by physical, right? So by physical reality, I'm referring to changing, even though I said earlier on, my argument doesn't depend on this definition, right? But nevertheless, if you press me, what I mean by physical, I would say that physical reality refers to changing entities which are describable by physics, right? Say, for example, about the equations of physics. And this is what scientists have found concerning our present world. Our world is describable by these equations. And I argue that these changes, which are describable by equations, do have a first cause creator. Okay, so that is my argument. Now, if you want to suggest the possibility that there could be a changeless or eventless physical reality, not describable by equations as the initial state, I think you said something just now about timeless, right? If you want to say there's something like that, right? Well, that is fine, but it doesn't rebut my conclusion that the stars and galaxies that we do observe ultimately come from a first cause who has libertarian freedom and who is a designer, as I've argued. So it doesn't rebut my conclusion, right? Now, on the other hand, so that's my second point. Okay, so now I move on to my second point. My second point is that, on the other hand, I have shown that a timeless entity would need to be changeless initially, and it will need to have libertarian freedom, right, to bring about the first event. And therefore, such an entity is not a regularity, not a regularity of events that's describable by equations of physics. And therefore, it is non-physical according to the definition I'm using, right? Because it will not be change, it will not be events, right? It will be rather it will be a personal creator. And so, and therefore, the point I want to emphasize here is that the theories that you cited, whether is it the LQG or Barber's theories, these theories could not have involved timeless entities in such a way as to exclude a creator God, which I've shown with my arguments.
So when I think about the properties that might make something temporal, I think of 3 different sets of properties. Think of the A properties, or the A relations, the B properties, or B relations, and C properties, or C relations, right? So I know that Andrew is probably familiar with all 3 of those, but for the audience's sake, here's what they are. So the A properties, my birth is to my past, but it wasn't always, right? So pastness, presentness, and futurity are properties that a given event has, and then it first it's to our future, then it's present, and then it's to our past, right? So that's what A properties are. B properties are they're similar in a way, but B properties are properties like before and after. But notice that those aren't properties that an event first has and then no longer doesn't have, right? So for instance, World War I was before World War II. And that relationship between the two of them, that World War II is later than World War I, is a relationship that the two of them have quite independent of where in time we might be. And then the C properties are properties that don't have this feature of directionality. So if we have 3 events, that we can say that which of the 3 is between the other 2, and that betweenness relation, that's what we call a C relation. Now, in my paper that Andrew has published a reply to and quoted from here, the paper that I published recently in Arquetness, I argued that loop quantum gravity, the fundamental structure of loop quantum gravity, is non-temporal in the sense that it does not satisfy A, B, or C properties. And and then in my opening statement, part of what I briefly, sorry, not my opening, my rebuttal, part of what I briefly said was that the fundamental substructure in loop quantum gravity doesn't undergo change because it doesn't have temporal location, right? Part of what it means, according to every philosophical conception of change with which I am familiar, is that part of what change involves is that first something has one property and then it has some other, right? First there's property P and then property not P. But if something doesn't have a temporal location, it can't first be located at one time and then be located at a subsequent time and have different properties at those two times, right? So if that substructure doesn't have doesn't satisfy A, B, or C properties, and it doesn't have a location in time, then it doesn't undergo change. It doesn't have any of the properties that philosophers typically think anything in time has to have. Now, why do I say it doesn't have temporal location, and why do I say that it doesn't satisfy the A, B, or C properties? Well, that's because of what's been called in the literature disordered locality. So in the way that loop quantum gravity works is that loop quantum gravity includes a kind of discrete structure that grounds space-time, right? So as understood in general relativity, space-time is continuous. Loop quantum gravity has this discrete structure. Now you might naively think, well, if it's a discrete structure, why couldn't it just be a discrete space-time? And then that wouldn't remove time from the fundamental part of the theory. Well, it's because the discrete entities and the relations between them do not correspond to the contiguity relations that you find in space-time. So the relationships among those discrete objects are a fundamentally different kind of relation than the relations that we find in the space-time that substructure grounds. In the case of Julian Barber's view, in the case of his approach to canonical quantum gravity, what I said was, so Andrew has said that that Barber defines time merely as passage, and that because he doesn't think that there's passage, he gets rid of time that way. Well, that's not how he gets rid of time in his approach to loop quantum gravity, which is what I was referencing, right? What he does in that case is he thinks that, and I'll go into more detail when Andrew has a chance to ask me questions, but in Barber's approach to canonical quantum gravity, what he does is he thinks that there are the fundamental arena of the theory, or the fundamental space within which the theory takes place, is a timeless distribution of properties over a high-dimensional space. And then the individual points in that high-dimensional space ground moments of time. You get C relations out of the relationship between those points. You get B relations out of those C relations by looking at the thermodynamic gradient in the resulting temporal series. And then he thinks that you get the illusion of the A properties once you have agents of a particular kind with which you populate your temporal series. But again, that temporal series is grounded in that high-dimensional space. The high-dimensional space itself doesn't include temporal relations. It doesn't include A, B, or C relations.
Just a quick,
certainly doesn't undergo change.
2-minute warning before we switch.
Okay, can I provide a response? So
sure.
Now the first point is that I think both of us agree, that none of these theories are proven, right? All of them are not proven. And the second point is that Barber, as I said, his definition of change and time is problematic, because if you read his book, The End of Time, on page 231, he talks about interference. And then if you talk about, on page 229 and 251, 252, he talks about the creation taking place all the time. Now, creation, interference, these are events, right? These are things that happen. And as I said before, whenever there's events, there is time. And Rovelli, which I cited earlier on, also says that in the LQG, there are events present. And the fourth point is that there must also be phase transition, right? So if you appeal to some disordered locality or discrete structure, whatever that is, right? That must still be able to transit or grounds or no grounds space the events time which we do observe, right? And so that transition itself would also be a kind of event. So in any case, there are events all the way down, and so regardless of whether you can talk about the ordering, is it A series, B series, C series, no matter what, there are events present. Regardless of whether you can localize them in any temporal location, there are events present, right? So, and whenever there are events, there is time. On my view, on the view that the cosmological argument requires. Yeah.
Yeah, there are no. That's not correct. But in any case, I'll let you go ahead with your, because my time is out. So I'll let you go ahead and ask the questions of me that you.
We just hit the 25-minute mark, so let's switch to Andrew asking questions to.
Yeah, let me pull up my notes for that.
Let me know when you're ready. Yeah.
Yes, I'm ready.
Okay, thank you.
All right.
Yeah, actually, the questions I'm going to ask are already related to the points that we are discussing, right? So, so you feel free to respond, and I can respond further. So, yeah, my first question, as you know, is about what is meant by the timeless aspect, right? Which I already mentioned just now. That I don't think. I think that they are not defining the terms properly because because on the one hand they talk about timeless, but on the other hand they talk about interference, they talk about emergence, they talk about things like this, which indicate that there is events going on. And so I think what I think is that Rovelli's article is really helpful, right? Because it clarifies that if you want to talk about events, there are definitely events, right? And so that's a point. Now there's an earlier part to my question, which concerns your analogy for non-metric time, right? So you mentioned in your opening statement, you mentioned the analogy of a line with points without labels. But isn't it the case that even without the labels, there are still points, which on your view represents instants? And isn't it the case that instants are events and changes that happen, right? That's what instants mean, which means that there is time even if we cannot measure it, right? So this is two questions.
All right. Well, your question is several different components, as you described, and so what I'm going to do is I'm going to break them down and respond to each one. So first, you asked whether, in the case of non-metric time, there is still time, and the answer is that yes, of course, non-metric time is still time. But I want to add a caveat. You said that we cannot measure non-metric time, and I want to make sure the audience understands. Well, it's true. Sorry, while that's true that we cannot measure non-metric time, there's something more fundamental going on there. It's also true that an interval of non-metric time simply doesn't have any length. If an interval of time is non-metric, and there simply is no fact at all as to how long that interval is. Now, second, you asked what it means to say that physical reality could have a timeless aspect, and whether timelessness would involve the absence of events or changes. As I've already said, for an entity to change, the entity needs to have a property at one time that the entity does not have at another time. And as I've already explained, in Julian Barber's approach to canonical quantum gravity, time is explained in terms of a timeless substructure. The substructure does not have a location in time, and so does not undergo change. A similar conclusion can be reached for loop quantum gravity. Now, you've made the claim that all that Barber means by timelessness is that the apparent passage of time is an illusion, so that Barber's view is compatible with the static or B theory of time. Unfortunately, I think you've misunderstood Barber. Barber denies that A, B, or C properties are fundamental. For Barber, the A properties are explained psychologically and indexically, the B properties are explained by thermodynamics, the C properties are explained by the best matching condition. What he ends up with instead is what some people have called a D theory of time. Now, as Sam Barron, Christy Miller, and Jonathan Talent have recently shown in a series of experimental studies, people consistently and predictably have the intuition that without the A, B, or C properties, there is no time. You've also pointed out that Barber mentions this isn't the version of the question you sent me, which you didn't quite read, but I'll tell the audience that in the version that Andrew sent me, he mentions that Barber mentions the Wheeler-DeWitt equation. And you said that according to Aaron Wall, the fact that a time variable vanishes from the Wheeler-DeWitt equation means only that there is no absolute temporal metric. Well, the fact that Wall and Barber are both discussing the same equation doesn't mean that they are discussing the same argument. Your use of Aaron Wall's comment suggests that you think Wall is responding to the reasons that Barber has for thinking that time is not fundamental. But Barber has a distinct set of reasons for denying that time is fundamental. So it's not clear why we should think that Wall's comments are relevant. Moreover, Barber and Wall may differ on how we ought to interpret quantum mechanics. Surely we cannot settle that dispute by quoting an assertion made by one of them. Here's a brief summary of the technical situation with regards to Barber's view. In quantum mechanics, the core mathematical object is something called the wave function. In Newtonian physics, the equations that we use are defined in terms of the locations of objects in ordinary three-dimensional space. So you might have thought that the wave function was a wave in ordinary three-dimensional space, but you'd be wrong. Instead, the wave function is defined as a distribution of properties over the space of possible configurations that a system might have, that is, over what's called configuration space. Now, some physicists like Aaron Schrödinger and David Bohm, and some philosophers of physics, such as David Albert, Alyssa Ney, Barry Lower, and Jill North, have taken this mathematical fact quite seriously. They have suggested that configuration space is the fundamental arena for quantum mechanics, and somehow grounds ordinary three-dimensional space. Now, there's a standard procedure called the canonical quantization procedure for transforming a classical theory into a quantum mechanical theory. When you apply that procedure to general relativity, you end up with a version of the Schrödinger equation called the Wheeler-DeWitt equation. As Barber interprets the Wheeler-DeWitt equation, the fundamental arena for quantum gravity is the configuration space of possible three-dimensional manifolds, quotiented by translations, rotations, and dilatations. Barber calls this space shape space, and each three-dimensional manifold is the configuration of our world at some time. So for Barber, what we ordinarily think of as an instant of time is grounded in a point in shape space. We can construct C relations from the interrelationships between the properties at each of the points in shape space, that is, by what Barber has called the best matching condition. Now, given that Barber and Wall are not discussing the same issue, it's not clear to me that they disagree with one another. But if they do disagree with one another, merely quoting Wall doesn't tell us which one of them are correct. All that I need for my arguments to succeed is that we don't know which of the two are correct.
Now, my response to that is that, now, first of all, again, you quoted Barber. You say that he denies ABC and you say that he affirms D. But as I said, the problem with his view, he can deny whatever he wants, right? But the point is that he is being inconsistent because he mentions about creation, he mentions about interference, and all these things are events. And as I said, events, when there's event, there's already time. So I think our ontology should be that events are more fundamental, right? So if there's events, then there must be some location, right? Even though you cannot locate it at this point in time because your theory is limited, but that's the problem with your theory, right? So when there's events, there must be some locations, even if we cannot identify what location they are, what temporal location they are. And so, as I said, there are events all the way down. And also, I mentioned earlier on that and wave function, by the way, is also a description, right, of events, right? Wave, right, function, right, is also so. If you disagree with, if you say that Aaron Wall is not actually disagreeing with Barber, then that's fine. I mean, my argument doesn't depend on that point. But what I'm saying is that we must be careful here, right? How to understand the wave function, but in any case, right, it doesn't rule out events. On the other hand, there must still be events, as I already explained, right? So that shows that the time must still exist. And then finally, just to remind the audience again, none of these theories are proven. On the other hand, I already provided a deductive proof to show that the uncaused beginner's first cause would have to have something with libertarian freedom, right, which means that there's a creator God. Yeah.
Right. So look, on your view, it might be that events have to be fundamental, but that's not something that you've attempted to establish in this debate, and it's something with which someone like Barber is going to disagree. Now, look, the view isn't that events don't exist, right? I keep trying to stress this point. The view is not that there are no events or that there is no time, right? The question here is, how do we explain time and how do we explain events? Now, in a view according to are fundamental, maybe it's the case that there is no underlying explanation for the fact that there are such things as events or changes or whatever. But on a view according to which time is not fundamental, that's going to be a view according to which time exists, but it is an explanation in terms of something else. It's going to be a view according to which events exist, changes exist, but they have explanation in terms of something else, right? There's this underlying substructure.
Yes, I understand. Yeah, I understand your point. And my point in response is that so you on first point is that you agree that events do exist, right? And my point is that these events are things which begin to exist, and whatever begins to exist would depend on the cause, as my Motor-Stone's argument show. And all this, and therefore they must, following the rest of the steps of my cosmological argument, there must still be a first cause, which is the creator, right? So this conclusion is not rebutted. And the second point is that you said that your events may be explained by something more deeply in physics, which is non-event or non-change. But for that to transit right into event or explain or ground or emerge, right, for events to emerge from that, emergence is also events in itself, and this emergence would also involve the underlying structure in events.
Yeah, and I purposely chose views on which there is so in your paper responding to Meyer-Ketnes paper, you discussed the fact that I discussed this process that some people have called geometrogenesis, right? This process whereby somehow something that other than space-time gives rise or is causally responsible for or progresses into, or so that space-time emerges out of something else. But that's not the view that I've been discussing here. The view that I've been discussing here is one according to which it's not that there's first something that's not space-time and then there's space-time. Rather, the view is that there's space-time, and space-time is grounded in something else. Just as, it's not that like water exists first and then ice cubes can exist, right? It's that water is grounded in the water molecules out of which it's composed. Likewise.
Yeah, I understand that. Yeah, so I understand that they are distinct, these two distinct things, right? So I understand that you're talking about the second point now, which is not about grounding, and my point is that this grounding itself would also involve the ground in events, right? As it grounds the events, it will be involved in that event as well. Yeah.
So I don't understand this. So with the ice cube example, what is the event that? So there's this fact that the ice cube is grounded in the H2O molecules. What event would you refer to in that case?
Well, I don't think the water and the H2O is a good example, because here we are talking about facts, entities exist. We're not actually talking about events. We're not talking about change, right? Whereas so I don't think it's a good example.
Sorry, maybe I misunderstood what you were trying to say. So it sounded like what you were saying is a more general claim that whenever it's the case that X grounds Y, there has to be that thing that I just said, that X grounds Y, needs to itself be an event somehow, or needs to be involved in an event. Am I misunderstanding something? Like, can you help me out here?
Yeah, so my point is that for, say, if Y is an event that is grounded by X, right? Then X itself, if Y is something that emerged out of X or is grounded by X, then this itself would also involve the ground as and in the event too. Yeah. But in any case, I don't think this is crucial to my argument, because, as I said, right, as long as we agree that there are events, my argument goes through. So regardless of whether
I don't think so. Look, I didn't. Our debate is not whether or not there's a first cause for all change. Our debate is about whether or not the totality of physical reality had both a cause and a beginning. Now, if it turns out that there's some part of physical reality that couldn't have a beginning, even if every other part of physical reality must have a beginning, if there's any part of physical reality that couldn't have a beginning, in virtue of being timeless, for example, then physical reality as a whole didn't have a beginning.
Well, as I said, the context of our argument concerns the cosmological and teleological arguments, and so which attempt to show that there is a first cause creator and a
No,
designer.
look, you put that up on your
if you want to
first
say,
slide, but
yes,
the
so
motion...
that is the context of it. I think that is what many people are concerned about when they discuss these issues, whether there's a God
well,
or not.
that might be what many people are interested in, but the motion that we're discussing is not the Kalam argument or the designer. I mean, obviously, it's relevant for both of those arguments, right? Like the...
Okay, let me put it this way. Okay, let me put it this way. Okay, so you're suggesting that that's possible that there are also physical entities that are without beginning, right? And so suppose you are not denying my conclusion that there is a first cause which is also without beginning and who also has libertarian freedom. So now we have two beginningless entities, right? But on the other hand, I think we had to go by Occam's razor. I think we go by what is the simpler explanation, right? Given that the physics is unproven, right? On the one hand, on the other hand, we have a proof, to show that there is a first cause who is a creator. Right?
No,
I think
look,
we should accept
but when you say... when you say that you have a proof, what you mean is that you have this deductive argument. But I can easily formulate a deductive argument for, the various views that I mentioned. The fact that you have a deductive argument doesn't mean that your case is proven.
No, I've not only mentioned deductive argument. I mentioned the deductive argument with true premises. I already explained why the premises are true.
Well, but we disagree about whether those premises are true, right? Just as I could easily present...
You haven't raised any relevant objections. Yeah, you haven't raised any relevant objections to the premises. I mean, the whole thing you're talking about now, about fundamental thing, is not a relevant objection to my premises, as I already explained just now. Yeah.
Why not?
Well, because as I said, right, the thing that you mentioned just now about whether events can be grounded in something more fundamental, right? That doesn't deny that there is events, and as I said, my argument only depends on the existence of events, right? That is enough for my premise to show that there is a first cause. And first cause is a libertarian freedom, conclusion, creator, God, right? So yeah, so you haven't denied any of my premises actually. Okay, shall I move on to the next?
All right, if you want to move on, we can do that.
Yeah, because I've still got quite a number of questions to ask, right? So okay, now on the second. Okay, the second question is actually related to what we are discussing right now, right? Because not having labels doesn't mean that the line can be infinite in extension, right? Now you claim that there are various cosmological models which involve an initial non-metric segment, but isn't it the case that this line is still either finite or infinite in extension, which implies that contrary to what you say, there is still a fact as to how long the past is in terms of extension, whether finite or infinite, right? There is still a fact about that. Moreover, even if there are no labels, there are still events. And these events cannot be infinite, as argued by the Green-Ripple paradox or the Hilbert Hotel argument, or my argument from the viciousness of dependence regress, etc. And so your whole distinction between metric and non-metric time is in fact irrelevant for rebutting my cosmological argument.
All right, so your question has two parts. Let's start with the first part of your argument. The first part has to do with whether non-metric segments can be neither finite nor infinite in extension. I think it's important that we first become clear on what non-metric segments are. To say that a segment is metrical is just to say that the segment has a length. That's all that means. To say that a segment is metrical is just to say that the segment has a length, or an extension, if you'd like. So to say that a segment is non-metrical is just to say that the segment doesn't have a length or an extension. And so for that reason, you're right when you say that a non-metric segment is not infinite. However, you are wrong to say that if the segment is not infinite, then the segment must be finite. By definition, a non-metric segment simply doesn't have a length. Again, this is what it means for a segment to be non-metric. If the segment doesn't have a length, then the segment is not finite or infinite. Well, let's turn to the second part of your question. The second part has to do with whether non-metric segments must include a finite number of events or changes. Now, in your book and recent article published in Religions, you defined begins to exist as follows. something has a beginning if it is a temporal extension. The extension is finite, and it has temporal edges/boundaries. That is, it does not have a static closed loop or a changeless timeless phase that avoids an edge. On your definition, any non-finite interval lacks a beginning. If time was initially non-metric, since time wouldn't be finite to the past, there would be no beginning of time. Hence, whether the number of changes in the past is finite has nothing to do with whether, according to your definition, physical reality began to exist. Moreover, let's suppose that the first change requires the existence of a first cause, or the first cause did not itself begin to exist. A physical entity could have initiated the first change after having existed for some duration of non-metric time.
Okay, so I pointed out earlier on that, even though, as you say, even if I can argue that there is no infinite changes in the past, it doesn't by itself prove that there is a beginning, right? But still, it shows that there is a first cause, which would, as I explained, require libertarian freedom to bring about the first event. And I lost what I want to say just now. And you mentioned about, well, could it be a non-metric first cause? But I already explained earlier on that if it's a non-metric, non-personal entity, it will be unstable, right? So it wouldn't exist beginninglessly without the first event. And so it cannot be the first, and therefore it cannot in fact be the first cause, right? So the first cause will have to be something personal.
Sorry, can you repeat why the first cause has to be something personal?
Well, because as I said, if it's something impersonal and it brings about the first event, right? Then it will be unstable. It will have a probability of bringing about the first event, and it will show that you couldn't have existed.
What do you mean by
in the beginningless
thank you.
state?
What do you mean by unstable?
Well, unstable means that. Well, as I said, there will be a non-zero probability, right, for it to bring about the first event, and so this probability would imply that it couldn't have existed forever, right, or beginninglessly in the initially changed state.
But wait, so in non-metric time, there's no fact of the matter as to how long it's existed. It wouldn't have had to have existed for an infinite extension. In fact, in non-metric time, there's no such thing as an infinite extension of time, right? Because a non-metric interval is such that there is no fact of the matter about how long two non-overlapping segments of that interval are. So if we suppose that there's this...
So in that case, it will be beginningless, right? It will be without beginning?
Yeah.
Yeah.
According to your definition of beginning.
Yeah, that's right. But as I said, it couldn't have been without beginning if it's unstable.
But you said, but you said that what it means to be unstable is that it's going to initiate a change that's finite.
Yeah, let me put it more clearly. So what I mean by unstable is that it will have a disposition for changing with the beginning of the first event. You have this disposition to bring about the first event, right? So, and this an impersonal entity wouldn't be able to hold back this disposition. This means that the impersonal first cause could not have existed in the beginningless state and initially changed.
But why does it? Yeah. So look, there's this very old argument that theologians have talked about for a long time, the why not sooner objection, right? So some people have, this comes up in the Leibniz-Clark correspondence, for example. So some people have thought that, like Newton and Samuel Clarke both thought, that before the physical universe existed, there was just empty time. And then Leibniz objects, well, why did God choose that time to create as opposed to some other? Now, one kind of reply that people have had, people like Alan Paget and Richard Swinburne, have suggested that what gives time its metric, what makes it the case that there are facts about how long a given interval of time is the laws of physics. But before the laws of physics, there was nothing to set the metric for time. Now, that's on a theological view, right? According to which, before the law is to establish the metric of time, there's no fact of the matter as to how long it is that God had to wait. So that this overcomes Leibniz's objection to Clarke. But we can instead look at some physical theories on which, similarly, there's an interval in which time doesn't have a metric, and then on those views, when we ask about whether an entity would have to like wait some period of time or something, it's just a rehashing of the why not sooner objection, right? And the answer
it's not the same. It's not the same. Yeah, because my argument is not about why not sooner. My argument is about having a disposition and being unstable and being unable to hold back, right? The disposition. That's the point of my argument.
Yeah, but why would it need? So look, when you talk about holding back a disposition, what I normally think of is that I can prevent myself from doing something for some period of time.
Mm-hmm.
But if there's no fact of the matter about how long a given period of time is, then what distinguishes a case where you can't talk about, for example, like holding back from exercising your disposition like for a longer period or a shorter period. So I don't understand like what work this is supposed to be doing here.
Well, the work is that all this points to a first cause with libertarian freedom who has the ability to hold back, right? So, and in holding back means that it will be existing initially changelessly and beginninglessly without the first event. So it doesn't have to be hold back for a duration of time. It can be holding back in the state of existing without events and without beginning, and in that state, it is holding back. It's disposition. So an entity with libertarian freedom will be able to do that. Yes.
Right. So look, I don't understand what it is that you have in mind. What does it mean for this entity to withhold its disposition?
Really quick, Andrew, before you come back on that, we did just run out of time. So if you'd like, we could extend the discussion period if you both would like to. Otherwise, we'll try to wrap it up and move to some Q&A with the audience.
How long do we have left in the 2 hours that we've allotted?
Yeah, we've got about 20 minutes or so.
Okay, let's finish up the. If Andrew would like, we can finish up.
Yeah, no, I'm enjoying listening to it. So we do have we had one super chat. Let me actually just put it up right now. Andrew, hold your thought if you can.
Okay, I hope I can.
This one.
Yeah. Okay. Anyway, yeah. Carry on. This
one should be relatively quick. Let's see if we can get it up here. Dan, have you ever responded to Matt Adams' arguments?
I've spoken to Matt Adams, but I think on Discord, but I don't know which arguments he Converse has in mind. But
okay.
But I say Converse all the time on Discord. So if he wants to chat with me about that I'd be more than happy to do so.
Okay. All right. Well, that was it. We have some more questions, but if we have time, we'll get to them. Otherwise, we'll reserve most of the time for the conversation between the two of you.
I think we'll have time because we're about, like, I think halfway through Andrew's questions, maybe a little bit more than that.
Okay. Yeah. We'll go ahead and continue, Andrew.
Oh, okay. I think if I remember correctly, Daniel was asking me about what holds back. Is that right?
Yeah. So what does it mean for this entity to like withhold its disposition?
Yeah, so as I already explained, right? So an entity with libertarian freedom can freely choose not to exercise its powers to bring about the first event. So that's what it means to hold back.
Okay, so the view is.
Yeah, I still have a few more questions, but yeah, carry on.
Okay, well, no, go ahead. We can.
Okay, go ahead. Okay, fine. Yeah, in the meantime, you can think about further response if you want, right? But we can talk about that later. But because we are short of time, so let me go on to my third question. So you mentioned about the material principle, right? But you claim that the material principle is just as well supported from our experience as the causal principle. But isn't your claim based on the failure to understand that my modal slowness argument is not based on support from our experience? It's not based on that kind of inductive support in that sense, but it's based on deduction, right? So, and I already explained earlier on during my rebuttal that a symmetrical deductive argument cannot in fact be formulated for the material causal principle.
Well, both the truth and falsity of the causal material principles are logically compatible with theism. So while God couldn't cause something to begin without causation, theism is logically compatible with things beginning to exist without causes. Hence, the relevant question is not whether theism is logically compatible with the truth or falsity of either principle, but instead whether theism is metaphysically compatible with the truth or falsity of either principle. And hence, the question is whether either principle, or the question ought to be, whether either principle is metaphysically necessary. Now, I'm not claiming to know whether either principle is metaphysically necessary.
No,
Instead,
sorry. I think you're replying to my fourth question. I'm talking about my third
oh,
question now.
am I? No, yeah, I'm replying to your third question.
My third question is about inductive support, right? It's not about theism. And why are you talking about compatibility with theism? That's not my third question. That is the fourth question. Question 3 is about whether
Yeah, did I mix these up? I might have mixed these up.
Yeah, I think so. Because you're talking about something
Yeah,
else
no, I
already.
think
Irrelevant. Yeah.
well, okay. So, yeah, okay. Well, so, oh, no, you know what it was, I accidentally put this first paragraph in the wrong place. But anyway,
Okay.
here's what I have to say with regards to your third question. So I'm not claiming to know whether either principle is metaphysically necessary. Instead, what I've argued is just that there is as much reason to think that the causal principle is metaphysically necessary as there is to think the material principle is metaphysically necessary. And therefore, without a symmetry breaker, we shouldn't adopt one of the principles without adopting the other. Importantly, the material principle isn't merely supported by an inductive generalization. For example, the material principle is also strongly supported by rational intuition. So, for example, we might find it utterly counterintuitive to think that materials could spontaneously assemble themselves into a house without a cause. Likewise, many find it utterly counterintuitive to think that one could build a house without using materials. Aristotle found both sufficiently counterintuitive to rule them both out as impossible. So, in Aristotle's view, for something to begin to exist is a kind of change, and change always involves the actualization of a potential. Hence, Aristotle held that there needs to be some kind of substratum whose potential is actualized whenever something begins to exist. To put the point another way, whenever something is made, as a matter of metaphysical necessity, the maker needs to act on some pre-existing stuff. And likewise, Spinoza held that there is ultimately only one thing. Individual objects are modifications of the one thing. So whenever something begins to exist, what happens is that the one thing comes to have a new modification. A view similar to Aristotle's and Spinoza's remains with us today. As I've said, all of the objects with which we are familiar from everyday life are composed of particles, which are themselves excitations in various fields. For example, the electron is an excitation in the electron field. For that reason, as a matter of metaphysical necessity, an electron cannot begin to exist without the prior existence of the electron field. Hence, we know that for a wide variety of objects, it is truly metaphysically impossible for them to begin to exist without the rearrangement of explanatorily prior physical stuff. Now, I've already shown that a version of the modus tollens argument can be constructed for the material principle. For that reason, if the modus tollens argument does show that a violation of the causal principle is metaphysically impossible, then the corresponding modus tollens argument from the material principle shows that a violation of the material principle is metaphysically impossible. How can the material principle constrain what begins to exist? Well, suppose that the causal principle were false, but the material principle were true. In that case, the presently existing physical stuff would still constrain what physical stuff can subsequently come into existence. Hence, in the absence of the causal principle, pre-existing physical stuff would provide an antecedent condition that would make it the case that only X rather than Y begins to exist. So, for example, in a world that contains only the electron field, there would be no quark fields, and so there would be no quarks. So which field there are constraints which particles can possibly begin. Moreover, provided fields satisfy various laws in virtue of their essential properties, an electron can begin to exist only when the properties of the electron field are consistent with the electron beginning to exist. Furthermore, consider your example involving the electric field. You claim that the electric field cannot increase without being caused to do so. But you also claim that physical objects satisfy the laws of physics because of the properties that physical objects intrinsically have. In that case, the electric field satisfies Maxwell's equations due to the properties that the electric field intrinsically possesses. If the electric field were to spontaneously increase in amplitude within some region, then there would be a violation of Maxwell's equations. But a violation of Maxwell's equations would involve a violation of the properties that the electric field intrinsically possesses. It's metaphysically impossible for an object to behave in a way that is contrary to the object's essence, and hence, the electric field couldn't spontaneously begin to increase for no reason.
Okay, thank you. Well, that was a very long response. Now, I have a few responses to your response. Okay, now, first of all, you say something about inductive support. And here I want to clarify that, in fact, I don't agree with your inductive support because I do think that there are good arguments for substance dualism, which imply that it's not true that everything even came from a pre-existent material cause. But we don't have time to talk about this here, so I would lay this aside. My point focus on the deductive arguments, right? And your second point is that then you move on to talk about intuition, right? Now, I have never appealed to intuition in my whole arguments, right? So I think intuitions can be fallacious. Intuitions can be demonstrated to be wrong by arguments. And so what I want to focus on is the modus tollens arguments. Now, you claim that you can formulate a symmetrical modus tollens arguments, but I already shown earlier on that you can, in fact, not formulate a symmetrical point to my premise 1.1 for my modus tollens arguments, right? So it's not the case that other physical stuff will begin to exist uncaused. Why? Because if some material, if something began without material cause, right? Because that thing which began could still have been caused by an efficient cause, right? Which makes it the case that it is that rather than other things which begins uncaused, which begins to exist, right? So so the symmetrical argument doesn't follow for the material principle. Now you mentioned that what about Maxwell's equations, right? Now Maxwell's equation, which describes the field, and and also you also mentioned about what about some fields making it incompatible with other fields existing. Now, I think that all this, whether is it talking about fields or equations, this is in fact consistent with my premise 2. Okay? So the premise 2 of my argument is saying that we don't in fact see these things begin. We don't in fact see an electric field increase in strength for no reason, right? That's what Maxwell's equation says. And so I agree with you on that point. I mean, that point is the premise 2 of my argument. But agreeing with premise 2 doesn't deny the reasons for premise 1, right? So the reasons for premise 1 is that if in fact things do begin to exist uncaused and there will be no differentiation between X and Y until these things have already begun to exist and our circumstances is compatible with other things beginning to with things beginning to exist, then we'll have, say, for example, electric charges beginning to exist uncaused, and those electric charges would cause the electric field, right, to increase in strength, right, and that will still be consistent with Maxwell's equation, right, because if there's more electric charges, there will be greater electric field, and so so what I'm saying is that the order will be disrupted, right, and there cannot be other fields preventing this because those other fields will be disrupted by other fields, and so what we observe will be utterly chaotic, which is not the case.
Sorry, I don't understand several of the things that you said, so maybe I can ask you some follow-up questions. Okay. So you said that it's consistent with the circumstances that these charges appear and that the electric field increases and so on. I don't understand that because given the state of the electric field at a time, Maxwell's equations necessitate what the subsequent states of the electric field will be. So it's not consistent with the present circumstances that the electric field will spontaneously increase.
I think you have misunderstood my point about the circumstance, right? So what I mean by the what I mean by the circumstance is that I'm not saying that the circumstance prevents things. What I'm saying is that the circumstance does allow for electric field to increase in strength. That's all, right? Of course, in our day-to-day life, we know that these events are caused, right? So you have, so for example, you have to press a switch, right, before the field increase, and the circumstance and Maxwell's equation doesn't prevent that. I mean, the increase will be as described by Maxwell's equations. But my point is that so my point in raising 1.3 is not to deny that, right? My point is simply saying that there is no circumstance that makes it incompatible with things beginning to exist, not beginning to exist uncaused, right? That is a separate point. So
Well,
yeah.
So I still don't understand it, because part of the
Yeah.
so if we take the present moment, for example, part of what there is in the present circumstances is the electric field and the properties the electric field has now. But if those properties that the electric field has now necessitates what the electric field will subsequently do, then the properties the electric field has now are incompatible with the electric field spontaneously increasing in magnitude.
Okay, let me put it this way, right? So, because you also asked about let me put it this way. I think that the laws of nature, and as described by the equations, they are supervenient on the properties of things, right? So,
Yes.
yeah. So I'm saying that if something begins uncaused, then some other things with other properties, such as electric charges, for example, right? These things would also begin uncaused, because there will be no cause that makes it that only the former but not the later begin to exist. And whatever differentiate between these two things will only be had when these things already began. So which means that there will be no differentiating factor, right? That makes it there'll be no difference between x and y where beginning to exist uncaused is concerned. And the circumstance also doesn't prevent that as well, right? Because the circumstance is compatible with y beginning to exist, right? So there'll be more electric charges beginning to exist,
No.
and that would, yeah.
Look, but as I just said, look,
And so the
I've been
equations doesn't
assuming
prevent, right? Yeah.
I've been
Yeah.
assuming your account of laws, according to which the laws are explained in terms of the properties that objects intrinsically have. And then the argument was that the properties the electric field has now are incompatible with the electric field increasing in amplitude in a way that's inconsistent with Maxwell's equations. I mean, why would I say that? Well, that's because the reason the field satisfies Maxwell's equations is because of the properties that the electric field has, right? Like that's your view. And so if that's your
Yeah.
view, then you don't need, like, there is part of the present circumstance that is incompatible with with either like charges coming out of nowhere or with the electric field increasing for no reason.
Oh no, there's no incompatibility, because as I said, the equations are supervenient on the properties, so the properties are more fundamental, and those
Right.
properties and those. So, for example, the properties of a charge, it doesn't prevent another charge from beginning to exist, right?
No, but
There could
that's
be
not what
multiple.
I said.
Yeah.
I said
So,
that
so
the
what I'm saying is
properties
that.
of the electric field, and in the case of a charge like an electron, it would be the properties of the electron field that prevent it from just happening for no reason.
No, but as I said, the having one charge which caused the field, which the field is moving on, right? The charge doesn't prevent other charges by itself. It doesn't prevent other charges from beginning to exist.
I
If
never
so,
said that one
yeah,
charge prevents
I know,
another charge.
I know you never said that. But my point is that if something begins uncaused, then those charges, then other things such as charges would also begin uncaused, right? So the fact that you have already charges here doesn't prevent that, and so yeah, so that's my point.
No, but the what does prevent it? So if the charge is an electron, for example, what prevents an electron from just happening for no reason are the properties of the electron field. Like that's what it is in the present circumstance that prevents it.
Well, as I already said just now, the fact that there's field right now doesn't prevent increasing in field, right? I can switch
Yes, it
on by.
does. Look, the field has properties. The properties explain why certain laws apply to the field. That's the view that you have. And so given the properties the field has, those properties are incompatible with the field beginning to increase for no reason.
as I said, no, they are not incompatible, right? The fact that there is already field existing around me right now doesn't prevent me switching on the laptop, which increase the field further. And what I'm arguing is that if something begins uncaused, I don't even have to switch on the laptop. The field would increase. Yeah, that's my argument. And moreover, the properties will also change uncaused as well, right? Because if given my premise 1.1 and 1.2, there'll be no difference between the changing of properties and the beginning of the universe, where beginning to exist
Look,
uncaused is concerned. The universe began
but
uncaused, right? So
to
and so
confuse
the properties will change. Yeah, and if the properties
that's to
change, the laws will
confuse
change as
whether
well. Yeah.
that's to confuse whether something can happen for no reason with whether something can happen without a cause. I never made the claim that something can happen for no reason, right? Throughout, I've been assuming that there are reasons for why things happen. In the present
Yeah.
dialectic context, what we're talking about is we're comparing the material principle with the causal principle.
I agree. I agree with you. I agree too. I agree that, no, and in fact, that is premise 2 on my argument, as I said, right? So things do not happen without reason. Things do not happen without cause. That is not.
No, but hang on, but
that doesn't
the
deny
fact
the
that
reasons for premise 1, right? And you
the
have misunderstood
fact
premise 1.3, as I said.
the fact that there's no cause that constrains whether or not something begins to exist doesn't mean that things would just pop out of nowhere. I mean, there would still be reasons that would prevent them from beginning to exist.
Well, as I said, those reasons would need to require a differentiation between x and y. There will need to be a difference between x and y, right?
And they do.
And whatever, as I said, but whatever difference will only exist when they had already begun to exist, which means that they cannot do the work of differentiating until they had already begun.
The electric field has the properties that it has now. And those properties that it has now constrain what the electric field does in the future.
No,
that's your view, right? You have the view. You have the view that the laws. Well, hang on, but you have the view that the laws are explained by the electric field's properties, right? So if I'm looking for a description of what properties the electric field has, I look to the laws, right? Those just are descriptions of the properties that the electric field has. And now I ask, okay, well, given that description of the properties that the electric field has, can the electric field spontaneously increase in some region within some region for no reason at all? And the answer is no. The properties the electric field presently has constrain what it does.
No, the answer is yes, if some things do begin to exist uncaused, because there'll be no difference between that thing and the properties of those.
No, but there is a difference. I just told you what the difference was. The difference is that some future developments are consistent with the properties that the field presently has, and some future developments are inconsistent with the properties the field currently has. That's what distinguishes between one future development and another.
Well, but this inconsistency is based on the assumption that there are properties which hold and which ground the laws that hold, right? But I'm saying that those properties would also change without cause if something else begins uncaused. That is one.
Let me ask, on your view of the laws, would the electric field essentially have its properties, or would it just be an accident that the electric field satisfies the laws that it satisfies?
Yeah. So on my view, it will not be essential. Yeah. It will be. Yeah. It actually is dependent on whether the causal principle holds, I think. Yeah. So and I think that the causal principle, we don't have to defend that it is a necessary principle. I think it's enough for the cosmological argument to show that it is a principle that actually is the case. It doesn't have to be the case in all possible worlds. Why? Because I can think of possible worlds which are utterly chaotic. I mean, that is also possible worlds. Yeah, but in any case, my argument, but in any case, the causal principle does hold in this actual world. And because of that, the properties and the laws also hold.
Look, so your argument was that the properties could spontaneously begin changing if there weren't causes to constrain them. And now if someone thought that laws are explained by the essences that physical objects have, then it wouldn't be possible for the electric field to suddenly increase, because or in other words, it wouldn't be possible for its properties to spontaneously change because those properties are just what it is to be that electric field, right? If they're essential. So it seems like what's
No,
doing all the
no, I
work
think
for
that
you
that's also not
here.
true. I think that's also
Why?
not true because even if you claim that the laws are essential description of objects, right? My argument will show that new objects would begin uncaused as well, right? So,
But
um,
but hang on.
mm,
When I was offering my objection a moment ago, you said,
mm.
"Oh, but if the causal principle were false, then the properties that objects have could just
Yeah,
change for no reason." And now
the
there are
properties will change, objects will change as well. Yeah, so new
right,
objects
and
will
so
pop into existence
and,
uncaused as
and
well.
then
Yeah.
and then the reply was that, well, if objects have their properties essentially, if that's why they satisfy the laws that they satisfy, is because it's in virtue of the essence that those objects have. Well, then, given what essences are, they couldn't change their properties, right? I mean, that would be explanation enough, just that it's essential to those objects that they have the properties that they do.
Yeah, so if that view is correct, then it would deny one of my response. It would deny that the properties change. Um, but uh, but actually, now actually even that I don't think is the case because it could be that the properties change and the object becomes something else, right? So it is still it doesn't deny that the properties are essential to that object, but it's just the
If
object
it's
became something else. It
sure,
became
if
another
it's
object,
possible,
and
if
moreover,
it's
it doesn't prevent additional objects from emerging, right? So these are two responses. Yeah.
if it's possible, if it's consistent with the object's essence that it ceased to exist, then sure. But if it's not, if it's inconsistent with the object's essence that it ceased to exist within some circumstance, well, then that's explanation enough for why it doesn't.
Well, I think objects do change, right? So some things can change to another thing.
Some
Yeah.
things can
So
change, but when they
yeah.
do change, either what's going on is that its accidental properties, not essential properties, are changing, or the circumstances don't prevent that object from going out of existence.
Well, no, I think okay. So, for example, if you say that it is essential to water that is H2O, but that doesn't prevent the H from dissociating with the O, and you're left with hydrogen and oxygen, right? So
Yes,
you have changed
and
another
I
object.
I agree, but that's because
Yes.
those are circumstances that are compatible with its going out of existence. There are going to be other
Yeah.
circumstances that are incompatible with that.
So I'm saying that if something begins uncaused, then we will see this kind of changes also happening uncaused as well, because there will be no difference between that kind of change with and the first kind of change where beginning to exist uncaused is concerned. So we will
Okay,
have
I,
sea
I don't
water.
want, so look, I don't want to belabor this point
Mm.
anymore. I think if you want to move on to your next question, I'm happy to do that.
Okay, so
Yeah,
am I in my
and
last
let's what we'll probably need to do, because we're already about 10 minutes over time.
Ah,
Oh, okay.
Andrew,
well,
try to pick one more question, and then we can discuss that, and then we'll wrap things up.
okay.
I see. But actually, I think my last question has already been discussed earlier on, so I don't think I need to. Okay, okay, yeah, maybe one more. Yeah, question 4, right? Just now, because you claim that causal principle and material principles are good candidates for metaphysically necessary principles. Yeah, but doesn't this objection fail to realize that, well, it violates the laws of logic to say that God makes something begins uncaused because make is a causal notion? It does not violate the laws of logic to claim that God makes something begins to exist without material cause, right? And there is asymmetry there. And given this asymmetry, and also given that, as I already explained, a symmetrical modal Stone's argument cannot be given for the material principle, given that premise 1.1 cannot be reproduce. No, it's not symmetrical. The mere inductive support for the material principle is insufficient to ground the claim that it is a metaphysically necessary principle which God cannot violate. And so, given that the theists can argue that the inductive support is merely indicative of the order set by God for how things behave when they are left on their own, but this does not exclude the possibility of God bringing about things in a different manner.
All right. So again, this is a multi-part question, and I'll break this question up into its parts, and I'll answer each one. Before answering any specific part of the question, I want to remind our audience that I've offered more than just an inductive argument for the material principle, right? The material principle is supported both by rational intuition and by the modus tollens argument that I presented. Now, your first question concerned a purported asymmetry between the causal principle and the material principle. You're right that there would be a contradiction if God caused something to begin to exist that didn't have a cause. And that no contradiction is involved in the idea that God causes something to begin without rearranging physical stuff. However, I'm not sure why this should be relevant. The denial of both principles is logically compatible with theism. We should instead be interested in whether the denial of either principle is metaphysically possible. You asked whether, given this purported asymmetry and the asymmetry in terms of the modus tollens argument, I would agree that there is more support for the metaphysical necessity of the causal principle than there is for the metaphysical necessity of the material principle. I do not agree that you've provided an appropriate symmetry breaker. So no, I do not think that there is more support for the view that the causal principle is metaphysically necessary than there is for the view that the material principle is metaphysically necessary.
Okay, but you haven't replied to my explanation for why 1.1 is not symmetrical.
Could you, maybe you could remind the audience what principle 1.1 was?
Okay, 1.1 is that, and by the way, I also mentioned just now I don't agree with the inductive support and the rational intuition part, right? Okay, so concerning the modus tollens argument, 1.1 for my causal principle is that if something begins uncaused, there will be no cause, which makes it the case that only that something, say X, rather than other things, say Y, begin to exist. Now, you cannot construct a symmetrical point concerning the material principle, because as I already explained, if something begins not by transforming from previous material, it doesn't mean that there's no efficient cause that cause that to begin, right? So it doesn't mean that there is no cause, which makes it the case that only that X, but not other Y, begin.
Look, as far as I can tell, there is a perfectly symmetrical reply. So, look, if your reply was to consider what would happen if the causal principle were true and the material principle were false, right? So we consider something that begins to exist with an efficient cause, but not from pre-existing material. Conversely, I can consider a case where something begins to exist to a transformation of pre-existing physical stuff, but without an efficient cause. And in that case,
Without efficient cause?
Without an efficient cause, yeah.
Oh, yeah. In that case, so you're saying that there's only material cause without efficient cause?
That's
Is
right.
that what your material principle is about? Okay, I see. Okay, so in that case, so you are saying that what begins to exist still has a cause, right? It still has a cause, but it's a material cause.
Well, sure, but I want to make sure the audience is clear on this. What I'm saying is that there's no efficient cause in the scenario that I'm imagining, right? There's no like additional entity that comes in and makes it the case that this piece of matter transforms from one state to another, or however it's going to work. Instead, what's going on is that you have some bit of matter that, without the intervention of an efficient cause, transforms from one thing into another thing. And then the idea is going to be that what constrains what can happen there is just the properties of the matter that undergoes the transformation.
Okay, so now the first thing to note is that so on that principle, it is still true that whatever begins to exist has a cause, right? It's just that it's a material cause, but not efficient cause. And the second point to note is that,
look, I've been trying to shy
I know you're
for
trying
the
to.
audience's sake. I've been trying to shy
Yeah.
away from using the terms efficient cause, material cause, right? Ordinarily, in the language the audience is likely familiar with, when you say efficient cause, you're using what they mean by cause, right? Like the water that goes into an ice cube is the material cause of the ice cube, but in the way that like lay people are going to want to speak, it's the material out of which the ice cube was made, right? Not the thing that intervened on the water to make this transformation happen. So
No, I don't think so. I think in the ordinary language, I think we are talking about efficient causes as well, along with material cause, right? So if you're thinking about something, you're thinking about water becoming ice. You're not just thinking about water, right? You're thinking about what caused the water to become ice, and that's the efficient cause, right? That something changes.
yes, I agree. I agree that in ordinary circumstances, we imagine both that there's an efficient cause and a material cause.
Not
But
imagine there are.
well, sure, but look,
Okay. Mhm.
I was trying to simplify matters for the audience. I take it that
Mm.
when we use the word, or when I've been using the word cause, what I've meant by that is efficient cause. And instead of saying material cause, right, in the material principle, I don't mention causes, right? I just say pre-existing physical stuff, or however I stated it, right? So that
But you have to mention cause because you are trying to construct a symmetry argument to my argument, right? That whatever begins to exist has a cause. So
well, look,
you should
so
use the word
okay,
cause. Yes.
here's how I see the dialectic. On one hand,
Yeah.
there's the claim that if there's no efficient causes, if efficient causes are not required for things to begin to exist, then things can just spontaneously begin all over the place. Right? There would be just Italian villages popping out of nowhere or something. All kinds of things would pop into existence without a cause. On the other hand, there's an argument about material, whether if it's the case that something wasn't made from, whether it's the case that if things didn't have to be made from pre-existing materials, then things could just spontaneously, things wouldn't be constrained by what happened before. They would just come into existence. And the claim is that I think that these two arguments, the one given in terms of efficient causation and the one given in terms of material causation, are symmetric. I'm not seeing a symmetry breaker between.
Yeah, and it isn't symmetric because let me clarify that when I defend the causal principle using my Motor-Stone's argument, it is true that I've been focusing on efficient cause, but my argument is not limited to efficient cause. My argument is saying that if there's no cause whatsoever, right, for whatever begins to exist, then there will be nothing that makes it the case that only that thing, but not other things, beginning to exist, right? So if there's no efficient cause, no material cause, no cause whatsoever, and the things just begin to exist without any cause whatsoever, then other things or changes or whatever would also begin uncaused. That is the argument. Now you're trying to construct a symmetrical argument by talking about transformation from pre-existing things, focusing on what I call material cause. But as I said, that even if something can come into existence without material, it doesn't mean that other things would. Why? Because we can still explain the coming to be of the material as being brought about by efficient cause, right? So your principle doesn't exclude the possibility that there could be an efficient cause which brings about
No,
something
of
without
course
using
not.
material.
But
Yeah.
that's,
So
look,
and so there is still some cause which makes it the case that that special event happened. So it doesn't mean that anything goes, right? Yeah.
I
So
agree completely. Look, so I had a
that's
different
asymmetric.
argument about the, whether causation was fundamental, but when I'm talking about the symmetry between material causation and efficient causation, that argument is not an argument that things can begin without causes, right? That argument is supposed to be that, well, if there's a good case for things only beginning when there's an efficient cause, then there's also a good case for things only beginning when there's a material cause. And
No,
the
as I said,
consequence of that is that the totality of the physical world couldn't have had an efficient cause.
well, but I already explained that you cannot. That there isn't. It isn't the case that if you have good reason for the first, you also have a good reason for the second. Because as I said, premise 1.1 cannot be reproduced on a similar argument for the material principle. As I already explained that. Why? Because as I already said, if something begins to exist without being transformed from pre-existing material, it does not mean that there is no efficient cause which brings about that special event. And so, which means that that special event would be special in virtue of the fact that it is brought about by a certain efficient cause, right? So it doesn't mean, and therefore it doesn't mean that anything goes. So that is the point of asymmetry.
Well, I never said that anything did go, right? I mean, again, the thought experiment
You are
that I'm
trying to construct
presenting was one according to which we consider a state of affairs in which some physical entity undergoes a transformation without an efficient cause. And the claim is that it would still be constrained by the properties that entity has. Some transformations are going to be allowed and some are not.
Some transformations, um, some transformations are going to be allowed, but some transformations are not. No, I think now you're talking about another argument. You're no longer
No,
talking about a symmetrical argument, is it? Yeah,
no,
because
look,
I'm getting confused. Now it seems that you're going back to your earlier point about Maxwell's equations, about when you talk about constraints. I thought you
well,
were. I thought in
there's
the
a
present case you were
relationship
trying to
between
construct a symmetrical.
there's a
No, I think
relationship
you're
between them,
mixing.
but
I think
this
you're
is
mixing up
still
these two arguments.
no,
You're
I'm
mixing up
not.
these two arguments. Yeah.
No, look,
But I think okay, we need to distinguish between these two
but
arguments.
I think
Okay.
I think we
Yeah.
we want to finish up.
Yeah, unfortunately, I do think we need to go ahead and wrap up the show. I mean, what typically happens with these sorts of things is that it starts to get super interesting toward the end, and then we could just like literally keep on going for hours and hours and hours. And so we've got to like eventually reach a stopping point. So let's just go ahead and wrap up. And what I want to do to wrap up is give you both some time to kind of give some just overall thoughts of the whole debate so we can kind of get some concluding remarks. And let's try to stick to about, say, 3 to 5 minutes. And since, Dan, you went first, let's go ahead and give you the chance to go first, and then we'll close with Andrew, with his closing thoughts.
Yeah. Just one second here. Right. So to summarize what we've talked about tonight, we don't know whether physical reality had a cause or beginning. And physics cannot help us. The observable universe expanded from a hot, dense state, but that doesn't show us whether physical reality began. Philosophy can't help us either. We don't know whether physical reality includes an initial non-metric segment. We don't know whether physical reality includes any timeless aspects. We don't know whether physical reality had a cause either. We don't have good reason to adopt the causal principle without adopting the material principle. And lastly, causation plausibly has a physical explanation. If so, physical reality as a whole couldn't have had a cause. All right, well, that was how I summarized earlier. I think it's still what I want to stick with. So if Andrew wants to tell us about how he would summarize the debate.
Okay, sure. Yeah, we'll turn it over to Andrew.
Okay, thank you so much, Daniel, for this very interesting discussion. So let me close by saying that, so one thing that Dan has been trying to establish is that physical reality could have a timeless aspect without beginning, and therefore such a thing would also not require a cause. But I already pointed out that on the one hand, we do not have any well-established physics to prove that that is indeed the case, right? It's just could have, but there's no good evidence to show that it is actually the case. So, the arguments that Daniel has presented is not based on well-established science that shows that it is the case, but it's just a speculation on the one hand, right? On the other hand, I have presented a cosmological argument and also teleological arguments. And these two arguments are deductively valid arguments, and I also explain why the premises are true, and therefore the conclusion is true, right? So it's a sound argument. And so we can know that the conclusion is true, and the conclusion is that there is a creator, designer of what we observe, the stars and galaxies that we observe must ultimately come from such a first cause creator, right? As to whether there is some additional physical aspect that exists alongside the uncaused first cause beginninglessly, well, we have no good evidence for that, and so on the basis of Occam's razor, we don't need to believe in that, right? Rather, what we should believe in is that there is a first cause creator and designer, right? That is because that is what can be shown by my argument, which has true premises and they are deductively valid. And so therefore, we can know that there is a first cause, designer and creator in that sense. And also the arguments that Dan claims that there is a material principle which is symmetrical to the causal principle I presented, well, I've already shown that that is actually not true. Why? Because premise 1.1 of my modus tollens argument for the causal principle cannot be symmetrical, cannot be reproduced symmetrically for the material principle. And so the causal principle is not rebutted, right? It still holds. And also I showed that given the causal principle, which I've demonstrated, it cannot be the case that causality can be you cannot get away from this by simply claiming that causality could have a physical aspect, or it could be explained by physical entities, right? Because that doesn't rebut the modus tollens argument which I presented, which shows that whatever begins to exist has a cause. And so what I do want to argue is that there are events that really happen around us, and this is undeniable. Daniel affirms that as well. There are indeed events, and given the causal principle, every event will depend on a cause, and there cannot be a dependence regress, infinite regress, or circular loop, and therefore there must be a first cause that is independent. And then it can be deduced that this first cause is something that's libertarian freedom that can hold back its disposition from causing the first events, right? So it will be something that is free, and also something that is intelligent as well, which therefore explains why is it that the universe which we exist in and which contemporary physics discover has such a high degree of order. This is evidence for a designer of the universe. Thank you.
All right. I think that is going to do it for us tonight. Thank you guys for tuning in. Thank you to our debaters, Andrew and Daniel. Daniel, I saw in the live chat someone saying that you're heading to an after show somewhere. Is that on Discord or?
Yeah, I'll be on Discord for a little while.
Okay, so I'm not really on Discord. I don't know where I would help send people there, but well, maybe you can help me out. How can people find this after show?
I think it's by private invite only. So.
Ooh, okay then. I should.
Well, as far as I look, I think the way the Discord servers work. I mean, I would be glad for either of you to be there. As far as I'm concerned. If people know how to get to, I think it's going to be in the politics and religion server. I don't run the server. I just have an invite myself. So
Gotcha. Okay. Well, either way, I mean, enjoy your time there. I enjoyed the debate. There was a lot of aspects to it that were over my head, which I think is going to be true of the audience as well. But I think the benefit of having a debate like this is that we get to hear some really I mean, you guys have been, you've had your own back and forth and everything. And so it's just really valuable to let two people kind of go at it and really try to flesh out the issues as much as they can. So this is the type of video though, that you can watch probably 5 or 6 times and still get something out of it every time that you watch it. So, but again, thank you guys so much for coming on. I really appreciate you taking the time, spending some of your hours on this planet with me tonight. So
absolutely, this was a lot of fun.
Awesome.
Really appreciate the time of preparation and discussion with you, Daniel. Yeah, so it was good. Thank you so much.
Absolutely.
All right. Well, thank you guys for tuning in. Yeah, no problem. All right, we'll see you guys in the next Capturing Christianity video. See you guys. Hey, it's me again. Actually, don't leave yet. I've got something super, super important to tell you. So first of all, you're awesome. Like you just watched a really, really long video just now, and you're still watching it. That is actually pretty amazing. Secondly, we have literally hundreds of other apologetics related videos for you to watch on our channel. Go check them out. I've interviewed exorcists, hosted debates between Christians and atheists. I've even made response videos to atheists. All of that is available on our channel. Go check it out. Third, I rely on people that see value in my work, people like you that watch videos to the very end, to keep the lights on around here. Literally, this is how I feed my family. So if you see value in the work that I do, please consider supporting this ministry and becoming a patron. Links to that are in the description. Oh, and have I mentioned that Christianity is true?